Okay, welcome to the webinar for Chapter 4, the webinar disclaimer. This WebEx service includes a feature that allows audio and any documents and other materials exchanged or viewed during the session to be recorded. By joining the session, you automatically consent to such recordings. If you do not consent to the recording, please do not join or participate in the session. This WebEx service is intended to supplement the classroom experience. Duplication or redistribution of lecture capture recordings is prohibited without appropriate consent. Okay, we're going to talk about Chapter 4, and Chapter 4 covers a variety of items: mathematical functions, characters, and strings. I'm going to skip over this preliminary and the objectives, and I will also start off by saying that there are many mathematical functions available to us in the math class. Java provides many methods in the math class for performing common mathematical functions. And we have that availability to us without even using an import statement. It's in the java.lang package, and there's no need to do any import to get access to those math methods. Because we use math so frequently in computer programming, it's just available to us all the time. So let's just take a moment and reflect. We've been working with classes since the very beginning of the semester. Your Lab 1 was a class. Your Lab 2 was a class. Your Lab 3 was a class. Your in-class assignments, your pre-lab assignments have all been classes. And inside those classes that we've been designing and creating and submitting to me, there's really only been one method inside it, the main method. But classes can have a variety of things inside them. A class can have constants, it can have variables, and it can also have methods. We've only been working really with classes that have one single method, the main method. But the math class has constants, it has some variables, and it also has very many methods. And some that are mentioned here are categorized by trigonometric methods, exponent methods, rounding methods, min-max, absolute value, and random methods. Here are the trigonometric methods available in the math class. If you have a need to use sine, cosine, tangent, arc, cosine, arcsine, and arctangent, you can go ahead and invoke the sine method, pass it the angle in radians, and this would be in the math class, and it will return the answer. We're not going to be working too much in this class in trigonometric assignments, so I'm not going to spend much time on that, but you can go ahead and take a look closer at that at your convenience. We do work with exponent methods, and not so much logs, but powers, for instance, and square root. So here's an example where we can use the math.pow method, and we would pass it two parameters. Parameters are inside the parentheses, and each parameter is separated by a comma. So the first parameter in the pow method is 2. This is a positional parameter, which means that this is the base, and this is the power that you're going to raise that base to. So 2 raised to the third power using the math.pow method will return an 8.0. It works in doubles. Here's another one, 3, 2. So we're going to raise 3 to the power of 2, and it will return the results of 3 squared, or 9. It also works with decimals as well. You can pass it 3.5 raised to the 2.5 power, and that will return 22.91765. There is a square root method inside the math class. The way you gain access to that is to precede it with the math class name dot square root and pass it the argument 4, which will return 2.0. Again, it works in doubles. You can pass it 10.5 or a fraction, and it will return 3.24. That's the square root. There also is a cube root. You can take a look at that, but that's not often used. We do use the square root very frequently. There are rounding methods in the math class. We have a need to round very frequently. And I'm going to go right to the examples here. And here in the math class, we have the seal method, we have the floor method, the rint method, and the round method. And here are examples of using each one. I drew a little number line over here to the right in a north-south orientation. So if here is 0, and here's positive 1, 2, and 3, here's negative 1, 2, and 3. Well, if you do math.seal on 2.1, it's going to go over to 2.1 and go to the ceiling and go up to 3 and return 3. Math.seal on 2.0 will return 2.0. And math.seal of negative 2.0 brings you down to here, and it will return you to negative 2. Negative 2.1 will return you to negative 2.0. So if you go down to 2.1, which is a little past negative 2, it will return back the ceiling, which is negative 2. The floor works the exact opposite. So math.floor of 2.1 is going to return you back to 2.0. 2.0 will return 2.0. Negative 2.0 will return negative 2.0, and negative 2.1, the floor of that is going to drop you down to negative 3, right here. Okay, the rest of these are not that frequently used, but here is where you can go ahead and use rounding methods to get more appropriate answers rather than having these big long strings of decimals. There is the max method, the min method, and the absolute value method. And here are examples using each one. For the max value, you pass it 2 arguments, 2 and 3, it will return 3, the larger of the 2. 2.5 and 3 will return 3.0. Again, it's working in doubles. And math.min of 2.5 and 3.6 returns 2.5, and math.absolute value of -2 will return a positive 2 because it's the absolute value. And likewise, negative 2.1 will return a positive 2.1 using the absolute value method. There is a random method inside the math class. Now, we've used the current time in milliseconds, and using the modulus function, we could go ahead and get a random number between 0 and 9. Well, because we have a need to use random numbers quite frequently in programming, there is a method in the math class called the random method. And this generates any fraction, basically going from 0 all the way to 0.9999. Essentially, what the math.random method does is it goes off to the system clock in your computer and returns back the fractional second. Whatever fractional second exists at that particular snapshot in time is what gets returned. So it will randomly generate 0.000001 or 0.9999997 or something like that. So that would be 2 examples on each extreme that it would return, but it would be the fractional second. Now, if you want to generate other random numbers, you can go ahead and use this formula here, where we return math.random. So that's going to return a fraction. Let's say it returns 0.000001. We multiply that 0.00001 times 10, and we're going to get 0.00001. We cast that to an integer, and now we're going to have 0. So you can see that that little example generated the random digit 0, from 0 to 9. Likewise, if the math.random method returned back the fractional second, and it happened to be 0.912345678, Multiply that times 10, and you're going to get 9.1234567 And we're going to cast it to an integer, and it will just retain the 9. So you can see how this instruction will generate random integers between 0 and 9. This instruction here, 50 plus this times 50, will return a random integer between 50 and 99. So in general, the formula would be as such: a plus dot random, open and close parentheses. It doesn't need an argument passed to it because it knows what it needs to do. It goes to the system clock and gets the fractional second. Plus b will return a random number between a and a plus b exclusive. It excludes a and b. Skipping over the trigonometry or geometry. I want to talk about the character data type. Up until now, we've pretty much just worked with numeric data. And to review, for integers, the smallest area in storage that we can store an integer is in the data type called byte. That would be 1 byte of storage. It can handle a positive 127 all the way down to a negative 128. So rather small integers can be stored in a byte of storage of the data type called byte. The next larger integer area in storage, data type, would be short. And that covers 2 bytes. Whatever you could squeeze into 2 bytes of storage is what you could use for integers of the type short. The next size after short for integers is int. And that's a 4 byte area in storage where you can store much larger integers. And the largest is long, and that can store things like milliseconds since 1970. That's a very, very large integer. It's 8 bytes or 64 bits of storage where integers can be stored. Those are the integers. On the other side, there are decimals that can be stored, or floating point numbers. The floating point different data types, well, a 4 byte floating point data type would be the float, where you can store a decimal in 4 bytes of storage. If you need more precision, you could go ahead and store a decimal in 8 bytes of storage, and that is the double data type. So we've talked about numeric data types, and we've covered just about every one that we can use. Now we're going to go ahead and talk a little bit about character data. The char data type, this is a primitive data type, very similar to int and double and short and byte and long. Those are all considered to be primitive data types. Well, char is another data type. And this char area in storage is 2 bytes, and it can store 1 character. In this case, we are storing the character A in the variable called letter, and it's of the type char. This really should have 2 slashes indicating that this is a comment, but this is an ASCII character. You can also store numeric characters, such as the number 4 in character representation, an ASCII character representation. Keep in mind that whenever you're storing char variables, you need to go ahead and identify them with single quotes. Single quote A, close single quote. And this is the numeric character 4 stored into a variable called numchar. It too is also of the data type called char. Now we're going to talk about Unicode characters. Not that long ago, well, I should say quite a few years ago, when I first started programming, all we really needed was 1 byte to store all the characters on the keyboard. 1 byte can store a total of 256 different values, and there are a lot less than 256 characters on our keyboard. But because programming and computers have gone ubiquitous, and they are all around the world, and they encompass and embrace many languages beyond just English and the English keyboard. We've now had to expand the area in storage from 1 byte to 2 bytes to store character data. And that will also include double byte character sets, kanji code, Greek letters, smiley faces, wingdings, what have you. So there are quite a few different characters that can be stored nowadays, and we now need 2 bytes to store all those characters in. So a way in which you can represent character data is using the Unicode approach. And in this case, we are storing this Unicode in hexadecimal. So there are 2 bytes. The first 2 zeros represent the leftmost byte. The first 0 is the left half byte, and the right 0 is the right half of the left byte. And then the 41 is what has value in there, and that's in the rightmost byte. The left half of the rightmost byte and the right half of the rightmost byte. And this is in hexadecimal, so this 41 is actually a value of 65. 4 times 16 is 64. So we have 4 groups of 16 and 1 group of 1s. So that's a total value in decimal of 65, which happens to be the uppercase A. So this char letter, using the Unicode representation, is the same as using this ASCII representation. This Unicode 34 would be 3 groups of 16 and 4 groups of 1. And that's another way in which you can go ahead and declare and assign character data into a char data type. Note the increment and decrement operators can also be used on char variables to get the next or preceding Unicode character. For example, the following statement displays character B. We declared a variable called ch, it's of the type char, and we're initializing it to lowercase a. This lowercase a in ASCII representation is the value 97. So if you wanted to go ahead and represent that in 2 bytes, the left byte would be all zeros, and the right byte would have the value 97 stored in a bit configuration. So this lowercase a is actually a value 97. If I do a system.out.println line and I do a ++ch, which is a pre-increment on ch, it will take the value, which is 97, and add 1 to it, make it 98. And now, when we print this out, that character value 98 will print out the lowercase b, the next letter in the alphabet. Java code uses Unicode, a 16-bit encoding scheme established by the Unicode Consortium to support the interchange processing display of written text in the world's diverse languages. Unicode takes 2 bytes preceded by a \u, expressed in 4 hexadecimal numbers that run from hex zeros all the way to hex fs. So Unicode can represent 65,535 plus 1 characters. That's quite a few characters now available to us that we can store using the Unicode methodology. Okay, so ASCII code and commonly used characters. For instance, a character 0 all the way to character 9. The decimal value is a decimal 48 all the way up to 57. So these are the actual decimal values. If you put it in binary notation, you would put in a binary 48 for the character 0 and a binary 57 for a character 9. A Unicode value, which is pretty much the same thing except it's being represented in hexadecimal, says this is a Unicode 30, which is 3 groups of 16, which is your 48, all the way up to 3 groups of 16 plus 9, so that's 48 plus 9, brings you to 57. So it's the same range. For the uppercase characters, A through Z, those values in decimal are 65 to 90. Uppercase A is 65, and uppercase Z is 90. You can also represent it in hexadecimal using the Unicode value, 41 to 5 able. And if you translate those over into decimals, those are the equivalent values. Lowercase a to lowercase c is a value of 97 all the way up to a value of 122. Or in Unicode or hexadecimal, it's a hex 61 all the way up to a hex 7 able. Notice the difference between lowercase and uppercase is 32. So the 32-bit will be on. The 32-bit will be on for all lowercase characters. If you want to take a lowercase character and convert it to uppercase, you can subtract 32. And the lowercase a will go from 97 down to 65. And likewise, the same with the lowercase z to an uppercase z. There are some other escape sequences. We've already explored a few. We've explored, obviously, the new line, the \n, and the \t in some of our assignments for tabbing over. There are others, \b for backspacing, \f for form feed, \r for carriage return. If you want to go ahead and put a backslash in your string, use 2 backslashes, and you will then put a \n. If you want to put a double quote inside your quote, use \double quote, and you'll get a double quote inside your string. A lot of these escape sequences are derived from the old typewriter, where you would have a carriage return or a large printer that has form feed where it has fanfold paper, and you want to form feed to the next sheet of paper. These aren't used too frequently nowadays. Okay, here's the ASCII character set in decimal. What did we say the uppercase A was? The uppercase A is right here, and that works out to be a value in decimal of 65. Likewise, a lowercase a would be over here, and that is a value of 97. And here are all the rest of the characters, the ASCII character set, and their associated decimal values. If you have a need to work with them in hexadecimal, here is the hexadecimal table. The uppercase A right here is a hexadecimal 41, which is identical because it's 4 groups of 16, which is 64 plus 1, so it's a decimal value of 65 or a hex value of 41. And you can do the same thing with down to the Z. A Z is a 55 able, and lowercase a is a 61 or 97 in decimal value, and a Z, which is a 7 able. So that's your whole table in both decimal and hexadecimal. Now, casting between characters and numeric types. We could go ahead and code an integer I and assign it a character value, a char value, single quote A. And that would be the same as assigning a 97, a value 97, into this int variable called I. This is the same thing as if you declare an int variable called I, and you are casting the single character A to an integer and storing it into the variable I. Here we have a char variable C, and we are initializing it to a value of 97. It's not in quotes, not in single quotes, it's not in double quotes, it's not surrounded by anything. So it's going to take the value 97, store it into the variable called C. It's of the type char, and it will go ahead and represent the lowercase a. And this is the same as casting the 97 to a char variable and then assigning it into the char variable C. Comparing and testing characters. If you have a need to identify whether or not input coming in from the console is character, is it uppercase, is it lowercase, is it numeric data, or is it something else, you can look at these different zones and determine whether or not it is character data. For instance, if CH, which is of the type char, is greater than or equal to uppercase A, and CH is less than or equal to uppercase Z. Well, if it falls between uppercase A and uppercase Z, you can put out system.out.println CH is an uppercase character. If it's not, if it doesn't fall within that range, ask the next question, else if CH is greater than or equal to lowercase a and CH is less than or equal to lowercase c. If that's the case, it's a lowercase character. If it's neither, if it doesn't fall into either one of those ranges, you can say else if CH is greater than character 0 and CH is less than character 9, then we now know it's a numeric character. Okay, so there are some methods in the character class. There it was the math class, which had many methods, such as the POW and the absolute value that we have available to us. Well, there is also a character class, different from the char primitive data type. And the character class has the following methods available to us that we can use to determine whether or not a character is a digit, for instance, is a letter or digit. This is a typo. That should be letter or digit. Is lowercase, is uppercase, and then we can also take a character and flip it to lowercase or flip it to uppercase using these methods on the character CH. All of these is methods will return Booleans. That means you're going to get a true or a false. That was the character type. There is also another type called the string type. Now, we talked about classes, and the character type and the string type are actually classes. And what are in classes? Classes have constants, they have variables, and they have methods. So the character class has constants, methods, and constants, variables, and methods, and we just went through a few of those methods. And likewise, the string class also has constants, variables, and methods. The char type only represents one character. To represent a string of characters, use the data type called string. This is a term loosely used. It's a data type, but it's really a class. And when you have a class, you want to go ahead and create an object of that particular class in order to gain access to those methods. So what we're doing here now is kind of a shortcut way to create an object of the type string. We have a variable called message. It is of the type string, and we are initializing it to welcome to Java. Now what's really happening here is this variable is a reference variable. It's a reference variable because we are using the string class to create this object called message. And the message area storage is a reference variable that contains an address that points to the area in storage where the object resides. The object is the Welcome to Java object. When we create this object of the type string and the reference variable name is message, then we can go ahead and use all of the methods inside the string class on that object, Welcome to Java. String is actually a predefined class in the Java library, just like the system class and scanner class. The string type is not a primitive type. It is known as a reference type. Any Java class can be used as a reference type for a variable. Reference data types will be thoroughly discussed in Chapter 9 called Objects and Classes, but for now you just need to know how to declare a string variable and how to assign a string to the variable and how to concatenate strings and perform simple operations for strings. Simple methods for string objects. Well, once you create that message reference variable of the type string, you can then use these methods in the string class to explore and examine this string object. We can go ahead and type in message.length, open paren, close paren, and it will return the number of characters in the string whose reference variable name is message. We can do message.char@, and put a particular index, such as 0, and it will return the character at the specified index from this string. If our string name is Welcome to Java, back here, and I put in character 0, it will return the uppercase W from Welcome to Java. Concat S1 will take whatever string we're working with and concatenate it with another string whose reference variable name is S1. That concatenation takes two strings and puts them right up next to one another. You can take a string and flip it all to uppercase, like you did with the character methods, and also to lowercase, like you did with the character method as well. There's another trim method, which will return a new string with any white space characters trimmed on both sides. So for instance, if you had message over here, string message equals blank, 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 welcome to Java, blank, blank, close quote, this trim method will go ahead, if you type in message.trim, it will go ahead and remove those preceding blanks and the trailing blanks and just trim it down to where you have non-white space starting and ending the string. As I said, strings are objects in Java. The methods in the preceding table can only be invoked from a specific string instance. An instance is an object created from that string class. For this reason, these methods are called instance methods. A non-instance method is called a static method. A static method can be invoked without using an object. All the methods defined in the math class are static methods. We didn't have to create a math object to do the POW method or the absolute value method. We could just reference the class name, math.pow, to open paren 2, 3, close paren. Those are static methods, the POW, the absolute value. But the instance methods, the ones we just went through for string and character, you need to create an object before you can go ahead and invoke those instance methods. The syntax to invoke an instance method is the reference variable name, such as message, dot, method name, character @ and an argument. We could put a 0 in there and it will return back the first character in that string in the message reference variable. Getting the string length. We're declaring a reference variable called message. It is of the type string, and we are initializing it to welcome to Java. We print out the length of, now we can do message, and that will replace this message here with welcome to Java is, we're concatenating is, and we're concatenating message.length. And the length will be, I believe it is 15. getting characters from a string. We have a message, welcome to Java, and we have characters indexed starting at 0, going from index 0 all the way up to index 14. So there are a total of 15 characters in this string. The reference variable name is message. I can use these instance methods, character at 0, to return the uppercase W in message. Message.length will return 15, the length of this overall message, and message.char at 14 will return back the lowercase a, the last character in the message. Converting strings. We're taking a shortcut here and just actually hard coding in the string and saying welcome dot to lowercase will return a new string called that has lowercase welcome. Welcome to uppercase will return a new string, and it will flip everything to uppercase. And here's your trim method, where we're passing it this string that has some preceding blanks, some white space, leading and trailing, and it will remove those and just return welcome without the leading and trailing blanks. For string concatenation, you can concatenate. For instance, let's say you have already declared a reference variable of the type string called S1, and you also have another variable of the type string that you've declared and called it S2. You can now go ahead and concatenate S1 with S2 and assign it into S3. Another way of writing that would be to just write simply string S3 equals S1 plus S2. Because we work with strings so frequently, there are many shortcuts in working with strings, and they're just showing you some that the compiler will accept. 3 strings are concatenated. Here's another little shortcut. You can go ahead and identify that string, welcome, concatenated with 2 blank, concatenated with Java, and those 3 strings will now get assigned into this reference variable called message of the type string. Over here, we have a reference variable called S of the type string, and we are concatenated this string chapter concatenated with this value 2, and because we're concatenating a string with a value, it's going to treat this as a string, and it will become chapter 2. Here's another example. We have S1 of the type string. We're going to go ahead and concatenate this string called supplement, and we're concatenating it with the char uppercase B. And this will go ahead and append the uppercase B onto supplement, and we will have supplement B residing in S1. Reading a string from the console. We're getting scanner input, and we're asking the question, enter 3 words separated by spaces. Okay. Remember we said this is a scanner, this is an object now. So this is a reference variable called input. It's of the type scanner. These are not primitive data types like int and double. These are reference types. So we have a reference variable called input of the type scanner. We're going to create a new object using this new keyword, and that object will get populated with whatever comes in from the console, from the system.in. We ask this question, enter 3 words separated by spaces. Now we can go ahead and declare S1 to be of the type string. So this is a reference variable, which means this is a pointer pointing to another area in storage. that is going to contain the object called S1. And it's going to be initialized by using the next method from the scanner class on this instance of the scanner class, this input reference variable. And that's where we get, if I put in John Quincy Adams, this next method will take John Quincy Adams and store it into this string. This reference variable name is S1. I'm sorry, I have to correct myself on that. This next will take everything up to the first blank. So the first word in my console input, John, will get stored into S1. The next method will go ahead and take the next word from the console and put Quincy into S2. And this next method from the scanner class, operating on this object, this input object, will return Quincy Adams into S3. So that I've gotten 3 words using the next method from the scanner class to assign them into 3 separate string variables. And this will print out S1 is John, S2 is Quincy, and S3 is Adams. Reading a character from the keyboard. We're getting scanner input, so we are going to create a reference variable. The name of it is input, so that means it's going to have a pointer pointing to the area in storage where we're creating the object of the type scanner. And this new keyword will create that object, and we will use system input into this reference variable. Now that I've created that object, I'll ask the question, enter a character, and I will use the next line method from the scanner class on this input object, and it will return the entire line. The next method just returned each word, but the next line method will return the entire line. If I put in John Quincy Adams, this next line method will return the entire John Quincy Adams and assign it into S. And now I am declaring a char variable called ch. This is now a primitive data type, so there will be an area in storage of type char, 2 bytes, and what's going to get assigned into this ch variable is what has come from this object S of the type string, and we are using the character at 0, the character at method, and the index is going to be 0, or the first character in my string input. What did I say? John Quincy Adams. So the uppercase J would get assigned into this ch variable. System.out.println, the character entered is J. I'm going to skip over comparing the 2 cities. Obtaining substrings. Substring method on a string where you have a beginning index passed to it as a parameter. And you can also use the substring method and pass it 2 parameters. The first parameter is the beginning index, comma. The second parameter is the end index. So here we have a string. We'll say it's message. And now message.substring 0,11 says we are going to return back the substring that begins at element 0, which is index 0. It's going to start with the W, and it's going to go a long message until it hits 11, which is right here, and it will return back one before this index. Or you can think of it as the length. 0 for a length of 11. So we're going to go from here, 0, all the way to 10. And welcome blank to blank will get stored in some other string if you're assigning it into another string. If you need to reference this Java, you can write the code message.substring open paren 11. It's only getting one parameter passed to it, so therefore we'll use this method, begin index, and it will begin at 11 and continue all the way to the end of the string because we didn't put a delimiter using a second parameter to delimit how much of the substring we want. So it will just return back from 11 all the way to the end of the string. Finding a character or a substring in a string. Here are the methods. We have the index of method. We pass it a character. It returns the index of the first occurrence of CH in a string. If it doesn't find that particular character in the string, it will return a -1. And then here are some others. Index of the character from a certain point returns -1 if there's no match. Index of string, index of S, here are all the different last index of, and there's quite a few. Now here's a good time for me to hop over to my test chapter 4, because the best way to understand these methods inside the character class and the string class and using substrings is to put them in practice. Over here in NetBeans, I have a program called Test Chapter 4 right here, and as each one of these concepts comes across in the textbook or in a PowerPoint, I like to go ahead and code it and make sure it works. So I've done that for Chapter 4. So here's, for instance, all from way back when, the first few slides where it talked about the math class and using the 2 radians and the cosine methods. And here are examples that demonstrate these particular skills and these methods inside these classes. And here's your math pow, your math square root. Here I did a cube root on 27, and you'll see down here, cube root of 27 returns a 3. Here is the math random to return random integers from different zones. So I experimented with it, and I created a few simple statements, and I played with it so I understood it better. I suggest you do the same. Working with the char data, here is where I experimented with this. Here is where I experimented with the \b, the \f, the \r, \\, double quote, and I could look down here and see how it came out. Here is a section on working with lowercase and looking to see if it's a zone. So we have lowercase a, and it will come back out and say a is a lowercase character. Lowercase a is uppercase, false, a is lowercase, true. A is a digit, comes out as false. Here's where I added 1 to CH, and it now becomes a B. Actually, I did a post increment, so CH is still an A, and then I printed it out after the post increment, and it's now a B. Here we have a couple of strings. String S1 equals lowercase welcome to Java, and string S2 has the uppercase W in Welcome to Java. That's the only difference in the two strings, S1 and S2. And here's where I do a system.out.println. S1 length is, and I can now reference this instance of the object of the string object, S1, and invoke the length method on S1, and it will come back and say the length is 15. S1 equals S2, and here's where the code is, and it says it's false because there is a difference, a very slight difference, the lowercase w to the uppercase W. There's a compare to method where I'm comparing S1 to S2. And that comes back and it says the difference is 32. The 32 can be thought of as the 32-bit. S1 starts off with a lowercase w. S2 starts off with an uppercase W. The difference between those two in ASCII values is a 32-bit, 32 value difference. So this compare to method will go ahead and return the difference in the ASCII values. Now for some indexes, we can do S1 starts with welk, and I'm using S1 starts with, and I'm passing it this prefix welk, and it will come back and it's a Boolean, it will return true. Likewise, S1 ends with AVA. It does end with AVA, and it will come back and say true. S1 ends, well, we just did that one. S1 index of come, and I'm going to do S1.index of come, and the index of come is on S1 is 0, 1, 2, 3. Come begins at index 3, and here is the 3 that gets returned. S1.last index of E will return the last occurrence, the index of the last occurrence of E in S1. Here's the first one, that's at 1, 2, 3, 4, 5, 6. That's the last E is at index 6, and that's what gets returned there from this statement. Okay, so this is a good exercise that you should be doing where you can go ahead and exemplify and demonstrate and practice with these notions that come up in the PowerPoint and in the text. Finding a character or a substring in a string. We have k of the type int, and we're going to go ahead and pass it the index. If this is the string called S, we're going to pass it the index of the first blank. We have the string Kim blank Jones, so the first blank is right here. The index is at index 3, and we're going to assign that into K. So K contains the integer 3. We can now go ahead and assign into first name of the type string substring 0, K. So we're using the substring method in the string class to go ahead and take from element 0, that's from K, all the way up to 3, minus 1, and we're going to go ahead and store Kim into first name. Likewise, for last name, we can go ahead and take s.substring K plus 1 and start with the J, and we're only passing it one parameter, so it will go ahead and return back from element 0 all the way to the end of the string, and it will put Jones in last name. Okay, converting between strings and numbers. There are some other classes, the integer class and the double class. These are all wrapper classes, but inside these classes are methods. And we can go ahead and use the parseInt method on some integer string and store it into an int value of the type int, and do the same thing with a double using the double class. There's a parseDouble method in the double wrapper class on a string of type that would be of doubles and store it into a double value. It's rather confusing, so let's just go to an example so you have a better understanding. I have a string. It has integers inside that string, 1, 2, 3. I'm going to go ahead and store those character digits into a variable called int string. It's of the type string. Now I can go ahead and use the parseInt method on int string and store it into int value. It's of the type int. So I've gotten character data coming in. Even though it's integers, it's still character data. And if I need to do any kind of arithmetic operations on that input, even though it's integer character data, I need to convert it over into an int. And the way to do that would be to use the parseInt method in the integer class, and it will now go ahead and store the value 123 into this int variable. I then go ahead and increment int value by 1. So 123 should then become 124, and sure enough, here it is printed down here. Int value is 124 from this statement. Likewise for the double, I have a character string coming in. It has numeric characters, and it looks to be of a double 123.45. This can get converted over to a double. So I'll use the parseDouble method in the double class. This is a wrapper class. And I'll take double string from here and assign it into a double called double value. Then I can go ahead and increment double value by 1. And 123.45 will now print out 124.45. Okay, so let's go to the next. Skipping over that and going to a hex digit to decimal. We do know the valid digits for hexadecimal numbers are 0 through F, 0 through 9, and A through F. It says here, write a program that converts a hexadecimal digit into a decimal value. Here's the program, hex digit to decimal, and we're getting scanner input. We're asking to enter a hex digit, and we're going to use the next line method to capture that particular digit. Let's assume for the moment that I put in the character C. Well, this next line method is going to take the entire entry, whatever I put in. I only put in one character, but this input is going to get stored into hex string of the type string. First thing I'm doing is check to see if the hex string has exactly one character. Well, the way to do that is to ask the question if hex string.length is not equal to 1. If it's not equal to 1, then I have bad input. And I'm going to put that out. System.println, you must enter exactly one character, and I exit my program with a return code of 1. And my program ends. But in my case, I put in a character C, so I'll skip over this block and I'll go to the next instruction here, which says display the decimal value for the hex digit. Now I know the character C is a value of 12. What I can do now is flip the character C and make sure it's uppercase. So upon the hex string object, I'm going to go to character at 0, which is C, and I'm going to flip it to uppercase. Now I have an uppercase C getting stored into the variable ch of the type char. Now I can test, is that uppercase C less than or equal to F? And is the uppercase C greater than or equal to A? That is true. It falls between A and F numerically. So therefore, I go ahead and I execute this block of code between this curly brace and that curly brace, and I will go ahead and take the characters uppercase C, subtract an uppercase A. Now what's C minus A? The value C minus the value A is going to be 2. Then I'll add 10 to that and arrive at 12. The value 12 then gets stored into this int variable called value. And then I print it out. The decimal value for hex digit C concatenated with is concatenated with the value 12. Okay, let's say, for instance, I entered a 7 rather than a C. Well, it wouldn't fall within this range here, so I would skip over this block of code and execute this next sequential instruction and say else if character is digit. Now I'm using the is digit method from the character class on ch, and I put in a 7, it will return back true. So this whole expression here will evaluate to true, and I will execute what's inside these curly braces and print out system.out.println the decimal value for hex digit 7 is 7. And then finally, if neither of these cases is the case, then I will go ahead and execute this final else clause, which says that I put in some invalid input. So here's a way in which you can capture hexadecimal characters. Okay, the printf statement. Up until now, we've used the print line, P-R-I-N-T-L-N. That is a method. We've also used just a straight print, system.out.print method. And the difference between the print line and the print is the print line will obviously go to a new line. The print will just continue to append or concatenate onto whatever was printed last without going to a new line. Well, we have now another print method. It's called the printf method. And you can use this to format output, especially when it comes to such things as currency. In a few of our assignments, we've had currency output where it may have come out to be $12.50 even, and we put out 12.5 rather than 12.50. Well, this printf method will allow us to format that such that it formats perfectly like currency. After all, up until now, the formatting has been for arithmetic. If we arrive at an answer and it's 12.50, we don't put out 12.50, we put out 12.5 in arithmetic. But in currency, we want to carry the pennies, so we would need to now put out 12.50. This printf method will allow us to do that. Let's look at an example here. We have some code here. Let's make it bigger. I've got a variable called count. It's of the type int, and I'm initializing it to 5. I have another variable called amount. It's of the type double, and I'm initializing it to 45.56. I now am using the system.out.printf, so print with formatting, and I'm passing it 3 parameters. We're opening the parentheses. The first parameter is this big long string, followed by a comma, followed by this variable count corresponding to this, and this variable amount corresponding to the above. This amount corresponding to this amount here. If we look inside the first parameter, which is the big long string, the string consists of count is, and now I have a %D, and amount is %F. These percent signs here, the %D corresponds with this next parameter, and this %F corresponds with this parameter. The %D says this is going to be a decimal integer. And sure enough, a count, the count variable, is an integer. It's a decimal integer. This %F says that what's going to get put in here is going to be a floating point number. %F is for a floating point number. And correspondingly, this variable, this last parameter, amount, corresponds to this, which in fact is a floating point number. It's a double. So everything corresponds, and this will display count equals 5 and amount is equal to 45.56 and 4 zeros. It's still not exactly how I want to go ahead and display a dollar amount. I want to get rid of those trailing zeros. Let's look at the example that I put together in my NetBeans. I have the same code here. Count is 5, amount is 45.56, and I do count %D and amount %F, and here are my corresponding variables corresponding to the %D and the %F, and it will print out count is 5 and amount is 45.56 and 4 zeros. I adjusted this now, and I said a new line. Here's another example, and I have %3D, %2S, and %4.2F, and a new line, all inside my first quote. And my next parameter is an integer, 1, 2, 3, 4, and sure enough, that corresponds with the %3D, which is a decimal integer. The next is a string. I put Java, so %2S will say that this is a string, and then the last is a double, 51.6653, and this is a %F. Now I've got some coefficients in here. I've got some values in front of the D, S, and F. What are those? Well, what this 3 says is that we're going to go ahead and reserve at least 3 characters for this display. Now, I'm displaying 4 characters, so that's fine. But if I was only displaying 2 characters, it would lead it with a leading blank. In this case, I am reserving at minimum 2 characters in this string. I happen to be displaying 4 characters, so I have plenty of room to do that. But if I was only displaying 1 character, it would lead it with a preceding blank. Here is where it really comes in very beneficial. And this 4.2, this says I've got a floating point number, and I do 51.6653. And what I'm reserving here are at least 4 positions, 4 characters and 2 decimal places. So this is larger than 4 characters. This is actually 7 characters, including the decimal point, and it will carry 2 decimal places. And down here, you'll see this example displays 1, 2, 3, 4 Java and 51.67. So this actually rounds this 51.6653 to 51.67. So it actually does the rounding as well. Another example, I do the same thing, %D, %3D, %2S, and %42F, and I use a different number here for the double. In this case, I'm using 51.0016653, and this will print out to 2 decimal places because of this, and at least 4 characters. And I'm printing out 7 characters here, so I now have 51.00. It will round on the 1,000th place and return back to 51.00. So this printf method right here is a very valuable tool, but you have to use this as described in this example. I would strongly suggest you go to the textbook and read the section on the printf, the full description, because that gives the full, all the details on how this printf method works. That does bring us to the end of chapter 4. And as a supplement to chapter 4, I've also included some hex arithmetic that will be on the midterm, so you're going to need to know how to do hex arithmetic. And I'll just quickly go through that, and then we'll call it a night. Hex arithmetic we can think of place values for base 16 on the left-hand side here. So let's think of our Unicode characters, for instance, where we have 4 hexadecimal characters. They can all be placed right in each one of these boxes. Each one of these boxes represents a power of 16, or for base 16 or hexadecimal. So 16 to the 0, anything raised to the 0 power is 1. 16 to the first is the 16s column. 16 squared is the 256 column, and 16 cubed is the 4096 column. This is for base 16. If you want to think of things in binary, well, that's base 2. So your first column here is your ones column, 2 to the 0. Anything raised to the 0 power is 1. So here's your ones column. Then here's your 2 to the first, or 2's column. Your 4's column is next, then your 8, then your 16, 32, all the way out to 32K. To convert, you're going to need to know how to convert from hexadecimal to decimal. And what we have here is a hexadecimal FF and how to convert that over to a decimal 255. Another example would be to convert 17 in base 10, 17 decimal, over to hexadecimal, which would be a hexadecimal 1-1. One group of 16s and one group of 1s adds up to 17, the value 17 in decimal. You may have a need to also convert from hex to binary and binary to hex. And here is a byte in storage. This byte has 8 bits all on, and that can be represented as a hexadecimal FF. The easiest way to do that is to draw a line down the middle of the byte right here. The left side is going to be the left half byte, and the right side is going to be the right half byte. And the 4 ones on the left can represent an 8, a 4, a 2, and a 1, which is a total of 15. In hexadecimal, that's represented as an F. On the right-hand side, we have 4 ones as well. That's an 8, a 4, a 2, and a 1. That adds up to 15. So that also is going to be represented in hexadecimal as an F. This one here is a little bit different. You can think of it as no 128s, no 64s, no 32s. We have a 16. We have no 4s, no 2s, and one 1. And that's going to be a total of 17, the value of 17. One group of 16s and one group of 1s. Another way to go ahead and represent that is to draw the line down the middle, and the left 4 bits will represent one hexadecimal character, and the right 4 bits will represent another hexadecimal character. For hexadecimal, we have no 8s, we have no 4s, we have no 2s, we have a 1. And over here, we have no 8s, we have no 4s, no 2s, we have a 1. So there's your 1 in 1 in hexadecimal. Okay, binary to decimal. Do the same thing. Start off by saying I have no 128s, I have a 64, I have a 32, no 16s, no 8s, I have a 4, a 2, and a 1. Add that all up and it comes to 103 in decimal. 153 in decimal, well, you can say I'm going to pull out a 128. No, I'm not going to pull out a 64. I don't have enough for 32. I can pull out a 16, I can pull out an 8, and I can pull out a 1. And that will add up to 153. Arithmetic operations. You'll have a need to go ahead and add 2 hexadecimal numbers, and what you should do is put them on top of one another. So we have hex 1 Abel Baker added with a hex 21, and that overall answer will be a hex 1 CC. Subtracting and a hex F2, and subtract from that a 1B, and we'll get a D7. Binary addition, you can do it 2 ways. You can add them together. 1 plus 1 in binary is 0, carry the 1. Have to carry a group of 2s. 1 plus 1 is 2, but you can't write 2. You've got to put a 0 down and carry a group. So now I have 1 plus 1 is 0, carry the 1. 1 plus 1 is 0, carry the 1. 1 plus 0 is 1. I have 1 plus 1 is 0, carry the 1. 1 plus 1 is 0, carry the 1, and here's 1. So that's a tedious way in which you can go ahead and add in binary. Maybe an easier way, might be to convert this over to decimal and say I've got no 128s, I do have a 64, I got a 32, and I got a 4, 2, and a 1. That all adds up to 103. Over here, I can convert this to decimal. I have no 128s, I've got no 64s, I do have a 32, I have an 8 and a 1. They add up to 41. I can add these two together. 103 and 41 is 144, and then convert it back over and pull out a 128, no 64, no 32. I can pull out a 16. A 128 and a 16 adds up to 144. I'd like you to go ahead at your convenience to try doing these examples here. BAB plus 1DD. Next, for hex subtraction, do hex DAD and subtract a 1B from that and see what the result is. Likewise, do this binary addition. These are your answers for those exercises, and I'd like you to go ahead and convert the following. I'll give you the decimal 22, give me the hex equivalent, and also give me the binary equivalent. I'll give you the hex, convert that to decimal using pencil and paper, not computers or calculators, and also give me the binary. Do all of these conversions, and I do give you the answers, so you can double check your work, but I want you to do this independently without a computer or a calculator and see if you can go ahead and do that. Here's another slide where you can go ahead and do hex addition of these two. Hex addition would be to go 2 plus 2 is 4, and then F plus 2 is f plus 1 is 0, and another one is 1, so it's going to be 1, 1, 4. And here's your answer here, 1, 1, 4. B plus 2 is D. 7 plus A, we can quickly convert the A to 10 and say 7 plus 10 is 17, but I can't write 17. I have to carry a group of 16. So I'll put the 1 down and carry a group of 16. And now I have 1 plus 1, and I get 2, 1D. Over here, I have B plus C. B is 11, C is 12. 11 plus 12 is 23. I can't put 23 down here. I have to go ahead and put 23, take 16 away, and I'm going to have a 7 remainder, and I'm going to carry a group of 16 over here. Now I have F plus 1 is 0, plus another 1 is 1. I carry the 1, and I have A plus 2 is C, plus the carried 1 makes D, and my answer is D17. That's how I would go ahead and do that hex addition. Hex subtraction, A minus 2 would be 8, and 4 minus 2 would be 2. B minus C, I can't do that, so I need to borrow a group of 16s over here. So this B is really an 11. I'm going to borrow a group of 16, so 11 plus 16 is 27. I'm going to subtract C, or 12, from 27, and I will be left with a 15. 15 in hexadecimal is an F. I borrowed one from over here, so this is now F6. And I can't subtract C from 6, so I have to borrow a group, so I'll change that to be E. And 6 plus 16 is 22, minus 12 is 10, which is a hex A. And I've borrowed one from the F, making this E, so this is an EAF. And I'll leave the last one for you to do. This is only going to come to you if you practice. So you need to go ahead and practice these for the midterm. And that's it. Are there any questions regarding tonight's Chapter 4 and Hex Arithmetic webinar? Okay, I see that Leah joined us. Welcome. Are there any questions before we call it a night? Okay, well, thank everyone for attending, and we will see each other again soon. Take care and have a good night.
You too, Professor. Thank you.
This WebEx service includes a feature that allows audio and any documents, other materials exchanged or viewed during the session to be recorded. By joining the session, you automatically consent to such recordings. If you do not consent to the recording, then please not join or participate. This WebEx service is intended to supplement the classroom experience. Duplication or redistribution of lecture capture recordings is prohibited without appropriate consent. We got that behind us. Now let's go ahead and take a look at Chapter 5, which is loops. It starts off by talking about if you have the need to write, for instance, from the computer, welcome to Java 100 times, it would be a tedious process given the skills that you've developed up till now. You'd have to do system.out.println, welcome to Java 100 times, copy and paste and repeat and do it. This particular chapter is going to introduce loops to you so that essentially to do the same thing, you would do these 4 instructions right here. You initialize count as an integer to 0, and then you introduce a while loop. The while loop opens with a parentheses, and you're going to test, and you're going to continue on in that loop for as long as what's inside the parentheses yields a true evaluation. So inside the parentheses is what's known as a Boolean. It can either be true or false. In this while loop, for instance, here we have while count is less than 100. Well, count is initialized to 0, so clearly right from the beginning it's going to be true. And we will go ahead and execute this statement right here, welcome to Java, and print that out. And then we increment count to be 1. The while loop goes from here to here, so it will go back again, and now count is 1, which is still less than 100, and we continue looping along until eventually count is equal to 100, and in that particular case, then count less than 100 is going to be false, so this loop body will not execute, and we will go to the next sequential instruction after the while loop. So that's essentially how a while loop would accomplish the same thing as writing system.out.println 100 times. We're going to now start getting closer to flowcharts. Flowcharts are going to become our friend. As we work with loops and logic, if, else if statements, nested loops, it gets very, very confusing. And in order for you to understand someone else's program or understand how you're going to solve a particular problem, it's always a good idea to use a flowchart. Here is an example of the flowchart that we just described, the while loop flowchart. And to the left, we have the while statement. And inside the parentheses is what gets evaluated to either true or false. This is what's known as the loop continuation condition. And the loop starts here at this curly brace and ends down here at this curly brace. So while the loop continuation condition is true, you execute the body of the loop. The flowchart for this looks like this. You're processing, and all of a sudden you come to a diamond-shaped box, which is a decision block. That is going to yield either a true or a false, which is really the while loop continuation condition. And if the continuation condition is true, you'll note that you do the statement or statements, the loop body, and keep looping until eventually the loop continuation condition is false, at which point you kind of flowchart around the statement or body of statements or the loop body to the next sequential instruction thereafter. For example, we initialize count to be 0, and while count is less than 100, we're going to go ahead and write welcome to Java, and we're going to increment count each time we iterate through the loop. The flowchart would look like this. This rectangle is an assignment statement, or it's an assignment block, or a process block. And in this case, we are assigning 0 into count, and then we are dropping down into the next question, which asks, is the count less than 100? It is 0, so we will come down here and process writing welcome to Java 100 times. Once count equals 100, it will no longer be true that it's less than 100, so we take the false branch and we skip around the loop body and continue on with your program. So those are two flowcharts to give you an idea as to how the flowchart would look for a while loop. Tracing the while loop, I'm going to kind of move over because we just did that. And go right to this repeat addition quiz. Quite a while ago, we had a, in listing 3.1, we had an addition quiz.java, which gives a program that prompts the user to enter an answer for a question on addition of 2 single digits. Using a loop, you can now rewrite that program to let the user enter a new answer until it is correct. So let's look at repeat addition quiz. Here's repeat addition quiz. I'll make it a little bit larger. And the first thing that we're doing is we're generating 2 integers using the system.currentTime milliseconds, modulus 10, and then doing it again by dividing by 7, integer division 7, and doing a modulus 10 on that, just to kind of give it a little bit of a shuffle. And we will have two numbers generated, integers, stored in number 1 and number 2. Next thing we do is we create the scanner. So we're going to create the reference variable input of the type scanner. And now we go ahead and ask the question, what is whatever generated number 1 is, concatenated with plus, concatenated with number 2, and follow it with a question mark. And we will get the answer. Let me run this so we can follow it with some example data. Okay, it's asking me what is 8 plus 6. I will say 14. You got it. Let me do it again. And I will do 0 plus 0. I'll say 1. That is the wrong answer. 2, 3. So it'll keep going in this loop until I eventually get the right answer of 0. And then I finally got it. So that's how this program works. So we've generated two integers. And let's do it again so we get something. 2 and 1. Okay, and I'll say 2. Wrong answer, and then I'll do 3. All right, so we'll use 2 and 1. So number 1 is 2, and number 2 is 1, just to make it confusing. All right, so number 1, so while number 1, which is 2, together added with number 2, which is 1, so that's a total of 3, is not equal to my answer. And in this case, my answer the first time around was 2. So it's not correct. It's going to tell me I got the wrong answer. Try again. And then I will go ahead and get another read from the scanner object and store it into answer. And then if answer the second time around, I put 3 in. And now while number 1 plus number 2, so 2 plus 1 not equal to 3, that's false. So we'll drop out of this loop and say you've got it right. Now I want to go ahead and focus in on something here that's very important. Let me just tighten up this up a little bit. I don't need this create scanner. I think we know what that is. The structure of this loop demonstrates a standard structure in using a while loop. Before you get to the while loop, the way you can design your solutions is to create what's known as a priming read. And in this case, we are using a priming read to get the first answer outside the while loop. So we use the scanner to get input, and we store answer in here. This is outside the while loop. And now you can test inside the parentheses to see if it's true or not. And then in the body of your while loop, at the very end, you go ahead and get another input from the console. So this structure where you have an outside priming read together with a repetitive read inside your while loop is a good structure to use when you're using a while loop. This comes up very frequently and can solve a lot of difficult problems by using this technique. The priming read, then go into your while loop, and at the bottom of your while loop, get your next read and continue looping and reading. All right, so that's your repeat addition quiz. Okay, write a program that generates an integer between 0 and 100 inclusive. The program prompts the user to enter a number continuously until the number matches the randomly generated number. For each user input, the program tells the user whether the input is too low or too high. So the user can choose the next input intelligently. We'll go through guess number one time quickly. Okay, what we're doing now is we're using a different way in which to generate a random number. We're using the random method from the math class. Between 0 and 100, we're casting it to an integer and we're storing it in number. Let's generate it. Okay, we now know that the number has been generated and it's asking us, guess the magic number between 0 and 100. Using our binary search technique, we're going to go ahead and split the difference. So 100 plus 0 divided by 2 is 50. So I will go ahead and enter a 50. This will optimize the amount of guesses. My guess is too high, so I need to go ahead and take the new max, which is 50, and the min, which is 0, add them together. I'll get 50 divided by 2, and I'm not in a loop. So that's not that much fun of a game. I only get one shot, so my guess was too high. And if you look at this code, you will see that if everybody could put themselves on mute, because I'm getting a bit of an echo, and I don't know whether or not it's my connection or just hearing myself back again. So if you could put yourself on mute, that would that hopefully will stop the echo. Okay, so what do we have here? We just have an if and else if. If the guess is equal to the number, yes, you got it right. Else, if the guess is greater, then say too high. Else, it's going to be too low. So that's rather straightforward logic using an if, else if, and an else. Now let's look at the same challenge using a loop. This is going to be just guess number. Okay, that's the extent of the program. Make it a little bit larger so you can see it. And in this case, it's basically the same kind of logic, except we're introducing a while loop here. And the while loop will continue on with this same logic, except you will be able to go ahead and narrow your search. So let's take a look by first playing the game. And it says, guess the magic number between 0 and 100. I'll use my binary search approach and do 50. 100 plus 0 minus, or divided by 2 is 50. My guess is too high, so here we go again. 50 plus 0 is 50, divided by 2 is 25. My guess is too high, so now I've got 0 and 25. Divided by 2, integer division is 12. So my guess is still too high. So I've got 12 and 0, so the middle is 6. It's too low. So now I know it's between 7 and 12. So 7 plus 12 is 19, divided by 2 is 9. And yes, that's my number. So hopefully you followed my logic in adding the max and the min, and then dividing by 2. And this will minimize the amount of guesses that I need to solve this particular problem or game. Looking at the code, we're going to generate the magic number here. We're going to create the input scanner, and we're going to ask the question. And in this case, while guess right here, it's initialized to -1. Here's another technique in which you can use a while loop, where you initialize a variable to a number. In this case, it's an integer, so it's valid, it's legitimate, because guess is declared as an integer. So guess is equal to -1, and then this is going to force us into this while loop. So -1 is not equal to number. It can't be equal to -1 because this random method from the math class will generate 0 to 100. So we're going to always, the first time, execute this loop body. And in here, we're now prompting for a guess. So this deviates a little bit from the priming read and then the read at the bottom of the loop. This is another technique or another way in which you can do things. I personally like the priming read myself, but here's another technique. All right, so we're going to now get a guess. In this case, what did I guess? I guessed 50, right? So if guess is equal to the number, yes, you print the number is whatever it is, if I happen to get 50 right off the bat. Else, if it's too high, put too high. Else, if it's too low, and I continue looping right here. And while guess is not equal to number, okay, I'm going to continue looping through, and eventually I will get the magic number. So here's a while loop, a demonstration of a while loop for this problem. Okay, now a math subtraction quiz loop. It generates one question for each run. We did something similar to this earlier in the semester. You can use a loop to generate questions repeatedly. This example gives a program that generates 5 questions and reports the number of correct answers after the student answers all 5 questions. Executing the subtraction quiz loop. All right, let's run this program so we see how this runs. What is 2 minus 1? 1. Whoops, I put it in the wrong spot. Let me back that out and put it right here. Okay, you are correct. What is 9 minus 9? 0. What is 6 minus 3? Let's say I put 2. It corrects me. It says I'm wrong, and it gives me the correct answer. What is 0 minus 0? 0. You are correct. 7 minus 2 is 5. So it asked me 5 questions, and it says your correct count is 4. I got 4 out of 5 correct. And it also kept track of my test time. While answering those 5 questions, it took me 28 seconds to do this test. At the very end, it also puts out kind of a summary of the questions and what I got correct and what I got wrong. Let's look at this code here now. It's not too long. And one thing I can see is that it has an awful lot of comments, which is very good. As a matter of fact, these comments are the algorithm steps. They're steps that are taken to solve this problem, the subtraction quiz loop problem. First thing that I do is I declare a constant called number of questions. It's equal to 5. We know it's a constant because it has the final keyword, which means that this number of questions cannot be changed. You cannot assign a number of questions to anything. It is declared as a constant. It's going to be 5 for the duration of this program. And now we have some other variables that are getting declared and initialized. We got correct count set to 0, count set to 0, and here we have the start time is going to be equal to the current time in milliseconds. At this particular point that this statement gets executed, the start time gets captured. We are also declaring a string variable called output initialized to the null string. A double quote followed by a double quote is the null string, and it is an empty string. Now we use our scanner to get input, and while count, what is count? Count is 0. Well, count is less than the number of questions. Okay, so it's definitely the first time. We're going to now, 1, get 2 random single-digit integers. And we'd use the math.random method to get integers between 0 and 9 and put them into 1 and 2. Using my example, the first one was 2 and 1. All right, so here we go again with number 1 is 2 and number 2 is 1. Okay, so we're going to have to flip-flop this because the 2 numbers, well, no, we're not. because it already was flip-flopped. But what this code is doing is it's saying if number 2 is less than number 1, we want to go ahead and flip-flop those numbers because this is subtraction, and we have to have a larger number subtracting a smaller number. If number 1 was equal to 1 and number 2 was equal to 2, then we would need to go ahead and create a temporary area in storage to store number 1, and then take number 2 and put it into number 1, and then take what was stored in temp and put it into number 2. That in essence flip-flops the two numbers so that the larger number is stored in the variable number 1. The next step, step 3 in the process, is to prompt the student to answer what is number 1 minus number 2. All right, we ask the question, what is 2 minus 1? And we get the answer from the console and store it into answer. The fourth step in the algorithm is to grade the answer and display the results. Well, if, now in parentheses, this is going to be a Boolean. Whatever's inside the parentheses is going to be evaluate or yield to true or false. And don't forget to use the double equals. That's the equivalency operator. That's going to be yielding a true or a false. Remember, if we use one equal sign, it's going to be an assignment operator. And it will be allowed to be used here, but you're not going to get the right results. So be cognizant and very careful to make sure that you are using the equivalency, the double equals, whenever you have an if clause, such as this. So number 1, 2 minus 1, equivalent to answer. I put 1, the answer is correct. So this whole thing evaluates to true, and I will execute this loop body, or actually it's not a loop body, the if block. And I will put you are correct, and I will go ahead and increment my correct counter by 1. Else we don't do that. And then down here, we increment the overall counter. So I've got 1 correct, and I've had 1 question asked so far. This is an interesting little statement down here. This is output plus equals, and then this big long string of concatenations. And what this output plus equals is, it basically is building output and summarizing every question and answer with all of these concatenations and storing it in output. And here's the end of my while loop right here. So output is continually getting built. It starts off with the null. Where's output? Right here, the null string. And now output is going to have a new line and going to put number 1, which is 2 minus 1 equals 1. And then that's my answer. And it's going to do the evaluation. Number 1 minus 2 is equivalent to the answer. And if it's correct, it's going to say correct. Otherwise, it'll say it's wrong. And you'll see right down here that it builds the first line for the first question. 2 minus 1 equals 1 is correct. And now we'll go back up and loop again and generate 2 more random integers, 0 through 9. It'll continue on with this process, and then once we're done with 5 questions, we drop out of the while loop, and then we take a snapshot in time using the system.current time in milliseconds to capture the end of my quiz, store it in a variable of type long called end time, and then I'll calculate the test time to be equal to the end time minus the start time. And then I finally print out the correct count is whatever my correct count accumulated to be up here, concatenated with a new line that says test time is equal to whatever my test time is divided by 1,000, because those are milliseconds after all. So I need to convert it over into seconds and then report it as seconds. And then at the very end, I put a new line out, and then I put my big, long accumulated output string. And that accumulated output string is from the 5 iterations in the loop, and it is output eventually will be this section here in blue. Okay, so that is the subtraction quiz loop. Okay, sentinel value. A sentinel is a guard at a castle. It is something that allows or denies entry into a protected entity, such as a castle. So a sentinel value in loops is to use a particular value to determine whether or not you should continue looping or not. Oftentimes, the number of times a loop is executed is not predetermined. You don't know exactly how many times you're going to loop. You may use an input value to signify the end of the loop, such a value is known as a sentinel value. And let's go through an example. Okay, a nice small program. Make it a little bit larger. All right, we're getting scanner input. We're asking the question, enter an int value, and the program exits if the input is 0. We'll run this here so we can see how it works. Enter an int value. I'll put 1, 2, I'm looping, 3, and then I'll hit 0. And I get out of the loop because I entered 0, and it gives me the sum of all of my integers entered as 6. This would be a good example for a cash register application, where you are processing items on your cashier's belt, and eventually you're going to come up to the last item, and you need to total it. Well, you can enter 0 because there really isn't anything that's sold in your store that's $0 or 0 cents. So you can use 0 as a very good sentinel value to exit out of the loop. So here we are asking for integers, and we store them into a variable called data. We're going to initialize sum to be equal to 0. And now while data is not equal to 0, so this is a priming read out here. And while data is not equal to 0, the first time in, I put 1. So while 1 is not equal to 0, I'm going to go ahead and take 1 and accumulate it into the accumulator variable called sum. So sum now has 1. And now I have, toward the bottom of my while loop, I have my loop read. And in there, I'm going to go ahead and ask the question, enter another one, exactly the same as up above. And I will go ahead and get my next entry from the console and store it into data at the bottom of my while loop. And I entered 2. So while 2 is not equal to 0, I will continue to accumulate sum. Eventually, I'll put 3 in, and then I'll eventually put 0. And while data, 0 is not equal to 0, that's false. So we get out of the while loop, and we drop to the next sequential instruction after the while loop, and we put system.out.println, the sum is whatever the accumulated amount is in the variable sum. Again, this is a very good example of using a while loop with a priming read and a sentinel value. This slide basically just says, do not use floating point numbers for loop control variables. We have a while loop where we're looking at item not equal to 0, and we're declaring item as a double. That's not a good idea because, as you know, floating point numbers are approximations. Whether it's a float or a double, it's an approximation. So as you increment or decrement your loop control variable, its approximations, and it may never equal 0. It may be very, very close to 0, but it may never equal 0. So this is a strong recommendation. Do not use floating point values to check your loops. All right, so that's the while loop. The next type of loop is the do while loop, and there's not really much to this. It's pretty much the same. The statement of body, the statements or the loop body occurs first, and then you ask the question whether or not you want to continue with this loop. If you do, you keep executing until you no longer want to continue on with this loop and you drop through. The structure looks like this. You start with a do statement, open curly brace, and then you have your loop body, all the statements that you want to do, and then at the bottom of your do while loop is where you tag on the while word, keyword, and inside the parentheses is going to be a Boolean, your loop continuation condition. It will be either true or false, and that will determine whether or not you continue looping or not. Don't forget the semicolon here. You need to put a semicolon. This is the end of a big do while statement. The third type, the last type we'll discuss, is the for loop. And the for loop has the following structure. Let's make it larger. The for loop has an initial, I'll lose that. I gotta go back. This right here is the first part inside the parentheses of a for loop. The first part is the initial action. In most cases, you're initializing a variable, your loop control variable. Let's say I equals 0. I, J, K, you can use any letter. Those are conventionally used for loop control variables, and they are of the type int, normally. So a good example would be for I equals 0. That's your initial action. It's followed by a semicolon, and then the next section is your loop continuation condition. Well, you're going to continue looping for as long as this condition is true. And then your third and final section inside the parentheses is the action after each iteration. What are you going to do? Most cases, you wind up incrementing the loop control variable, I++, such as what's going on over here. The for loop will go ahead and usually has a curly brace. If you only have one statement in your for loop, you don't need the curly brace, but more often than not, you need curly braces because you have more than one statement in your loop body. And then the for loop body ends at the closing curly brace. Here's the flow chart, and here is an example where we initialize I. We declare I as an int variable, and now we're setting I equal to 0. That's your initial action. And then this is your loop continuation condition right here, while I is less than 100. And at the end of our loop, we're going to go ahead and increment I by 1. And here we print out, welcome to Java. It will loop 100 times. Here's the flow chart. And we can skip through the trace. I'm sure you can follow this. This only does it twice. And then you fall through. What this is bringing up is that this initial action in a for loop can be a list of 0 or more comma-separated expressions. The action after each iteration in a for loop can be a list of 0 or more comma-separated statements. Therefore, the following two for loops are correct. They are rarely used in practice, however. Not a big fan of this one right here, okay? I would strongly suggest you don't write any kind of loop like that. But this I have seen in my travels where you have a loop control variable. Your initial action is to set I equal to 0 and set J equal to 0. And you're going to continue looping for as long as I plus J is less than 10. And you are going to increment I and increment J at the bottom of your loop every time. sometimes you'll see you'll increment I and decrement J. And you'll get some rather complicated loops, but this is essentially like looping within a loop. But you'll see this, and it does occur. I wouldn't suggest, and I've never really run into something that looks like that, so don't do that. It's saying here that the loop continuation condition of for loop, if it's omitted, it's implicitly true. I've never seen it. I've never seen anything that looks like this. I do see here frequently where they would use a while loop and using the keyword true, and then opening up the loop body to do some statements. And this is a while loop that will continue on indefinitely, because true will always be true, and it will therefore always execute this loop body. So you better make sure you have a way in which you can get out of this loop. Some forewarnings here. Be sure to not put a semicolon after your parentheses in your for loop. Essentially what that does is it just basically ends the for loop. And then you're just going to have one statement, you're going to print it out, and you're going to continue on. So this is not a compile error, this is a logic error. So you could inadvertently wind up putting a semicolon at the end of your for declaration, and this is no longer a loop, this is nothing more than just a statement. So be careful about your semicolons. Here's another one with a while loop. If you put a semicolon after the expression in parentheses, this is a logic error. It's not going to get caught by the compiler. And you'll process just once. You will not loop. And you will always process this system.out statement. Increment I, and then go to the next sequential instruction. This, however, is correct. In a do while loop, you do need the semicolon. The others, you do not. It will allow you, but it is a logic error. Which loop to use? Well, the recommendations basically say, use the one that's most intuitive and comfortable for you. In general, a for loop may be used if the number of repetitions is known, as for example, when you need to print the message 100 times. A while loop may be used if the number of repetitions is not known, and you might want to use a sentinel value, as the case of reading numbers up until the input is 0. And a do while loop can be used to replace a while loop if the loop body has to be executed once before testing the continuation condition. Next, we get into nested loops. Write a program that uses nested for loops to print a multiplication table. Here is a program that will go ahead and print a multiplication table running this. This has your multiplication table, your 1 through 9 multiplication table, all nicely spaced out and formatted in good fashion. Let's look at this code. First thing that we're doing is we are printing out the header, multiplication table with some preceding blanks so it can be indented and spaced out and balanced. Next, we print out a handful of blanks, which gets us to like right in front of this 1 right here. Now we've got a for loop, and we're initializing j to be 1. It's of the type int. And we're going to continue on while j is less than or equal to 9. And then we're going to increment j. There is no curly brace here, so this for loop only includes one statement. And we're doing system.out.print a bunch of blanks and a j. So we'll start with 1, and we're going to print this 1. And then we're going to go ahead and loop, and we're going to increment j. Now j is going to be 2. And we'll put some preceding blanks and then print a 2, and we'll loop all the way to the 9 in this for loop. Next statement is to go ahead and put a separator line. We'll go to a new line and put some dashes, and that will separate the header or the column headings. And now we have another for loop. And this for loop has more than one statement. We are declaring and initializing I equal to 1, and I will continue on for as long as I is less than or equal to 9. So it'll go from 1 to 9, and after each iteration in the loop, it will get incremented by 1. So I will become 1, and then it'll go 2 all the way up to 9. And here we are printing I, whatever, so the first one is going to be 1 concatenated with a vertical bar. And here's your 1 concatenated with a vertical bar. And now we have yet another for loop. So this is a nested for loop inside another outer for loop. And this particular for loop, we're using J, we're initializing it to be 1. We're going to go for J to be all the way up to 9, and we're going to increment J by 1 each time. And we are using the printf method here to print out the results of I times J. So in the first case, it's going to be 1 times 1, then it'll be 1 times 2, 1 times 3, 1 times 4. And this printf method says to go ahead and put out for at least 4 characters the decimal integer. So this should be separated by 4 characters all the way across. So here's your for loop that goes all the way across. It'll eventually print out the first row. And then we're going to go ahead and do a system.out.println line, which would go ahead and bring us down to the next. And we're going to now increment I to be equal to 2. And we put 2 with the vertical bar. And then we do the same calculation, and you can see how this whole thing works. So it's not a lot of code, but it is complicated, especially when you start getting into nested loops. This is where flowcharting comes in very handy. If you write this as Java code, at first glance it's kind of rough to see what this code is doing, but if you went and tried to write this on a piece of paper using flowcharting diagrams and symbols, I think it would be a lot more obvious as to what it's doing. Okay, so that's your multiplication table. This is repetitive. This is just using the test sum, again, using floating point numbers. They are approximations, so you may not get the test to be equal. All right, finding the greatest common divisor. We know what a greatest common divisor is. If you have 2 numbers, it's the largest divisor that evenly goes into both numbers. It says write a program that prompts the user to enter 2 positive integers and find the greatest common divisor. And the solution is suppose you enter 2 integers, 4 and 2. Well, the greatest common divisor is 2. Suppose you enter 2 integers, 16 and 24. Their greatest common divisor is 8. So how do you find the greatest common divisor? Let the 2 input integers be n1 and n2, so you know number 1 is a common divisor, because 1 goes into every integer. But it may not be the greatest common divisor. So you can check whether k, and for k, which goes from 2 to 3 to 4, so this k is just going to be incrementing, and so on, is a common divisor for n1 and 2 until k is greater than n1 or n2. In other words, it will continue on. You'll keep incrementing k until it becomes greater than the smaller of the 2 numbers. Let's look at greatest common divisor. I'm going to run it so we can see what our output looks like. Enter our first integer. I'll do 12 and 6. The greatest common divisor for 12 and 6 is 6. I'll do the first integer. I'll do 9 and 6. The greatest common divisor for 9 and 6 is 3. All right, we'll use this as our test data that we can go through. So we're going to get scanner input, and we're going to put what I entered was 9. That's going to be going into N1, and I'm going to go ahead and put 6 into N2. All right, we're going to set the GCD equal to 1, because we do know 1 goes into every number, so it's going to go into 1. It's going to go into 9. It's going to go into 6. So we'll start off setting GCD equal to 1. Now we're going to initialize K to be equal to 2. That'll be our counter. And while K is less than or equal to N1, N1 is 9, so 2 is less than 9, and 2 is less than 6. And that's true for both occurrences. So I have a true ANDed with a true. That's an overall true. I will go ahead and execute this loop body. And here I've got an if clause that says if N1, which is 9, modulus K, K is 2. So that's not equivalent to 0. We have a remainder. And it's followed by an AND. So I've got a false ANDed with a anything is going to be a false. So this statement will not get executed. And we will not put 2 into the GCD for 9 and 6. Now we bump K. Now K becomes 3. And while 3 is less than 9 and 3 is less than 6, it is, we're going to ask if 9 modulus 3 is equivalent to 0. That's true. There is no remainder. ANDed with 6 modulus 3 equivalent to 0. And that is true. I have got a true ANDed with a true. That's an overall true. So I will go ahead and execute the loop body, which is just one statement, and I will assign K, which is 3, into the GCD. And I will continue to bump K to be now 4. And it will continue on up until it hits 6. And when K is 6, when 6 is less than N1, that's 9, that is true. And K is less than or equal to, when 6 is less than or equal to 6, we're going to continue on with that. But once it gets past this, this is now 7, and it will be a false condition. So 7 will be greater than 6, and we no longer test to see if 7 or above is a greatest common divisor. It makes no sense because it's larger than one of the smallest number. And then we dropped out of our while loop, and we will go ahead and print the greatest common divisor for 9 and 6 is whatever I had stored, and the GCD greatest common divisor is 3. Okay, so that's using a rather short while loop. And let's see what's next. Okay, future tuition I'm going to skip over because that's nothing new to that. I'm going to go to the next one here. You can take a look at that. It's posted in Blackboard. Decimal to hex. Here's one that you should take a closer look at. Close all projects, and let's open up decimal to hex. All right, I'm going to go ahead and run this, and we're going to enter a decimal number. I'll put in, I don't know, 18. 18, the hex number is 1, 2. Okay, it's not a decimal 12, it's a hexadecimal 1, 2, which means it's one group of 16s and two groups of 1, which is a total value of 18. If I put in 255, which is the largest value you can put into a byte of storage. The hex number for 255 base 10, well, the hexadecimal value is FF, which is 15 groups of 16 plus 15 groups of 1. Add that all up, it comes to 255. I'll run it one more time, and I'll put in 123, and the hex number for value 123 is 7B as in Baker. Let's see how this program is converting decimal numbers into hex. We're using scanner input. We put in the decimal number. I put in 123. 123 gets stored into the variable called decimal. I am initializing a hex string called hex. And now I'm quickly going into a while loop. And while decimal 123 is not equal to 0, that's true, so I'm going to execute this loop body. And I'm going to take decimal modulus 16, and I am going to, that's the remainder function, and store it into hex value. Let me go ahead and pull up my calculator. Where's my calculator? Here it is. Okay, let's see if we can make this a little bit smaller. Put it over here. And now I am taking 123 modulus 16. Over here, I can change this view to be a programmer's calculator, and it changes this. This is Windows 10. It's a little different interface, but if you have a previous version of Windows, all these functions, although they look different in your calculator, they're all still here. So I'm going to take decimal, which is 123 modulus 16. I'm going to do 123 and modulus 16, and that's going to be equal to 11. Okay, so now 11 gets stored into hex value. I rewrote this code here because it's a little complicated using this technique here with the question mark and everything. I rewrote it to be a little bit more straightforward. So hex value's got 11 in it. If 11 is less than or equal to 9, it is, that's true. ANDed with a hex value, 11, greater than or equal to 0, it's true. 11 is greater than or equal to 0. So I've got a true ANDed with a true. That's an overall true. Well, then what I'm going to do is take the hex value, which is 11, and I'm going to add the character 0 to it. We need to go ahead and get this into a character hex digit. So we're going to add the ASCII value of character 0. The character value of 0 is a hex 30. And I am going to add 11 to that. Okay, so character 0 plus 11 is going to bring me up to a hex 3B, I guess it is. And this 3B is going to now get cast to a character, and this 3B is going to be equal to B. This hex digit is B. And now that's where you have the B, the 11, stored in hex digit. We don't do the else statement right here. And the next thing that we do is we take hex digit plus hex. Hex was initialized to null, so we're going to take the hex digit B and store it into hex. So now hex has the value, the character B in it. And we get to the bottom of our loop. We come back up here, and let's see. So we have, while decimal, which is 123, is not equal to 0. Here's a good example of where you should have a piece of paper and a pencil and writing down all your variable names and then keeping track of what they get changed to on paper with your pencil. Because all these variables are going to change as we loop, and you need to make sure you keep track of them. So what do we have here? I'm doing it in my head, and I believe we still have 123 as decimal. So we're going to Oh, we didn't do this right here. Sorry. We have to do this statement here. And so we're going to store decimal integer division by 16 and store it into decimal. Well, 123 integer 16, let's clear this. And we'll do 123 divided by, now this is integer division, we're dividing it by 16, and that's going to be equal to 7. So now decimal contains 7. And we go back up to the top of our while loop. While 7 is not equal to 0, that is true. We're going to take decimal, which is 7, modulus 16, and we're going to get what? We're going to do 7 modulus, where's modulus? Modulus 16, and that's going to be equal to 7. It's the remainder. We have a 0 quotient with a remainder of 7. And we're going to store that into hex value. So now 7 is stored into hex value. We have hex digit as a char data type. And now while 7 is less than or equal to 9, that's true, and 7 is greater than or equal to 0, that's true, we'll execute this statement and say the hex value, which is 7, and we're going to add a character 0 to it. And this will be, and the hex value is now going to be 37. That now gets cast to a character and stored into a hex digit, and that's going to be the character 7. So a hex digit will now contain the character 7. We don't do the else, and then we take the hex digit 7 and concatenate that to what was in hex, which was B. So this now gets evaluated to 7B. This gets stored into hex. So now hex has 7B. And now we're going to do integer division, decimal divided by 16. Now we have the quotient, which is 0. And we're going to come back up here. And while decimal, which is now 0, is not equal to 0, that's false. So we get out of the while loop, and we now come and print out the hex number is hex, which is 7B. So that's a very small while loop with what's inside it is an if and an else, but it's rather tricky. And this is where you need to have pencil and paper and trace all of your variables as they change throughout the loop. That's how it converts a decimal number over into a hexadecimal. Monte Carlo, I'm going to skip over. That's another way to approximate pi. And I do want to go and show you a test break and a test continue program that test the break and continue keywords. Okay, test break. We have a variable called sum equal to 0, number initialized to 0, and while 0 is less than 20, we are going to increment number. So 0 will then become 1, and then we're going to add the number into the accumulator called sum. So sum, after the first iteration, is going to have 1 in it. And if sum is greater than or equal to 100, we issue a break statement. Well, sum is 1 the first time around. And now we're going to go ahead, and while 1 is less than 20, it is. So we're going to make it 2. And we're going to add sum plus equals number is the same as saying sum equals sum plus number. So we're going to now add 1 and 2 together and store it in sum. And you're going to put 3 into sum. And if sum is greater than 100, we're going to issue the break statement. The break statement will get out of this loop, this while loop. So now sum has 3 in it. And as you can see, this will continue on until eventually number is equal to 20. And at the very end, we're going to print out the number is number, whatever the number is that it was accumulated to, and the sum is going to be reported as well. Running this program, you'll see that the number is 14 and the sum is 105. What is this program doing? This is adding up the integers from 1 to 20 and stopping once the sum is 105. And once you've stopped, you report what the sum is, 105, and also, when the sum is over 100. And so the sum happened to be 105, and the integer that got us over 100 is 14. So 14 plus 13 plus 12 plus 11, 10, 9, all the way down to 1 will add up to 105, and that gets us over 100. So this break statement, in effect, allows us to get out of this while loop. Let's look at the continue. All right, the same type of thing. We've got sum equal to 0, number equal to 0, and while number, which is 0, is less than 20, we're going to increment number. Now it's 1. And if 1 is equivalent to 10, that's false. It will, or, so it's an or, not an and, so I'm going to have to still evaluate the second half of the expression. So I've got a false ORed with number equivalent to 11. That's also false. So that is not going to execute the continue instruction. It will go ahead and execute this. And in this case, we're going to go ahead and take number, which is 1, and store it into the accumulator. And then we're going to loop back around and increment it to 2 and keep looping. And what this particular expression does is it says when it hits iteration 10 and iteration 11, we are not going to go ahead and add those two integers into our accumulator. So if number 1 equals 10, or if number equals 10 or number equals 11, we're going to issue this continue statement. And the continue statement says go to the bottom of the loop. So we go to the bottom of the loop, which essentially is skipping over this one instruction, but it goes to the bottom of the loop and then goes back up to the top and continues executing. This program will go ahead and sum up all the integers from 1 to 20, skipping over 10 and 11. And the technique used is the continue statement. So here's our break statement, where we break out of the loop and go to the next sequential instruction outside the loop body of the while statement, of the while loop, and the continue statement, which says basically to get to the bottom of the current loop that you're in and skip over any instructions after the continue statement. So those are two tools that you can use to get out of a loop. And here's the program for guessing a number. You can rewrite it using a break statement. We've done this before, so let's just take a quick look at that and test using break. Oh, I didn't queue that one up here. Let me get that. Guess using break. All right, what are we doing first? We're getting two numbers generated randomly between 0 and 100. We're storing it into number. Let's run this so that we can see what we're doing. Guess the magic number between 0 and 100. All right, your guess is, we'll go through the binary search and do 50. Guess is too high, so I'll take 50 plus 0, divide by 2, and I get 25. Guess is too high. I'm going to take 25 plus 0 divided by 2 and get integer division 12. and my guess is too low, so now I got to go 13 plus 25 is 38, divided by 2 is 19. Put that one in, and my guess is too low, so now I'll do 20 to 25. That's 45 divided by 2 is 22. And my guess is too low. I'm not that lucky this time around, so I've got 23 to 25. Add that up, it comes to 48 divided by 2 is 24, I think. And yes, that's my number. Okay, so you saw my approach. You saw what I did. Here's the code. Not too difficult. I'm generating the number. In this case, what number was it? My number was 24. And I use the technique of binary search. And this here is a while loop that is always going to execute. We're using the true keyword, so this will indefinitely loop. So that means that there better be a way out of here. Somehow there ought to be some break statement to get us out of this while loop. And then the rest of the logic should be straightforward and familiar to you. We're getting our guess, and if the guess is equal to the number, boom, we put out, yes, the number is whatever it is, 24, and we break out of the loop, out of the while loop. The while loop is the last thing that's done, so the program will end. But if it is not equal to number, then we execute the else if. If it's greater than, you put out too high, else it's too low. And you keep looping indefinitely until the end user eventually picks the correct number. All right, so that's an example of using the break statement in a while loop and also using the true keyword, creating an indefinite loop that would need to be exited by the break statement. I'm going to skip over the prime number. Everybody knows what a prime number is. It's a number that's divisible by itself and 1 only. And it's a rather interesting program. You can take a look at it. I also included a flowchart here that is pretty small, but if you do the replay, you can probably expand it and take a closer look at it. But this is how you would go ahead and print out, I think it's the first 50 prime numbers 10 to a line. And there's all these loops within loops. It's kind of complicated, but it does produce some nice results. Okay, I think that brings us to the end of Chapter 5. Yep, that's the end of it. Let's see if there are any participants that have any questions. I've got Drake, Julio, and Michael Shiro still hanging in there. Do any of you guys have any questions on what I went over? I know I went over it quickly, but it is being recorded, and you can go back and stop the recording and play with it in NetBeans and experiment. But do you have any questions at this point?
I just want to ask about the I++. You only use it within the for while loop right after the system, within the output, right?
Yes, the for loop uses the I++. You can also use J++. You can put them together. But that is conventionally what is used in the for loop. It's not used anywhere else. So you would need to put it in the while loop or the do while loop. The for loop, it's up in the top and inside the parentheses. Okay, good question, Mike. Did I answer it?
Well, yeah, partially, yeah. I mean, what if, well, you don't have to use the I++ on the other ones, which is not in the loop, right?
That's correct. Yes, you don't need to use I++. You can design your loops any which way you want. Oftentimes there is a loop counter. In some cases you could do while it's true. So there is no loop counter. Okay?
Okay, thanks.
All right, any other questions? Are we good, Julio? Drake? Okay, well, I guess we can call it a night. Thank you all for participating, and I will post this shortly in Blackboard. Take care and have a good night. This WebEx service includes a feature that allows audio and any documents and other materials exchanged or viewed during the session to be recorded. By joining the session, you automatically consent to such recordings. If you do not consent to the recording, please do not join or participate in the session. This WebEx service is intended to supplement the classroom experience. Duplication or redistribution of lecture capture recordings is prohibited without appropriate consent. Okay, what we're going to talk about today is the chapter on methods, chapter 6. It introduces an opening problem. The opening problem is to find the sum of the integers from 1 to 10, from 20 to 30, and from 35 to 45, respectively. Let me just see who just joined. We have, oh, nobody. Okay. All right, so you should recognize that this looks to be like the same code. The only difference is we have a starting point and an ending point that are different in each of the three different cases. 1 to 10, 20 to 30, and 35 to 45. But everything else is going to be the same. It's going to be the summation of all those integers within that range. Up until now, this has been the solution, which would be to write 3 separate routines. The first one to handle the range from 1 to 10 using a for loop and accumulating into an accumulator called sum, and then printing it out. And then repeating the code, initializing the sum counter or the sum accumulator to be equal to 0, and then accumulating the sum from 20 to 30 and print that out. And then finally for the third occurrence as well. That's not as efficient as the way we would want it. A better solution would be to go ahead and take these 3 routines and write one routine, call it a method, and make sure it has the following structure. Inside your main method, you would do 3 straight system.out.println statements and state the sum from 1 to 10 is, and then at this point, you invoke the sum method, passing it 2 parameters. The first is the starting point, and the second is the ending point. When you place values in those parameters, they become arguments to this method. So the first argument is the integer 1, and the second argument is the integer 10. Up here is the actual method description. We have public static int sum, int 1, and int 2. What that means, these first 2 words, public static, are modifiers. We'll talk more about that later in the semester. The next int is the return type that's going to come from this method. The method name is sum, and inside the parentheses are parameters. They're separated by commas, so we have 2 parameters. The first one is of the type int, and it will be referred to as I1 within this method. The second one is of the type int, and it will be referred to as I2. The method begins here. The method block begins at the open curly brace, closes down at the closing curly brace, and here is what we're going to do regarding the sum method. The first thing we're going to do is initialize the sum accumulator to be 0, and we just do a quick for loop where we start at I1, which in this case gets passed from this statement and this method call, and I1 will be 1 and I2 will be 10. Now what we'll do is we will accumulate into sum plus 1, then sum plus 2, sum plus 3, sum plus 4, and we'll eventually get the sum of all the integers from 1 to 10. It will then return the variable sum up here, and whatever that accumulation is will then get replaced in where this orange box is, and it will print out the sum from 1 to 10 and whatever that value is. The next invocation of the method is the second statement, printout statement, and it will pass two different parameters. It will pass 20 and 30. Those get put into I1 and I2, and we do the same process. And then finally, the third step is to invoke the sum method, passing it two different arguments, 35 and 45, and that will get the sum of 35 to 45. So this is a much more efficient way of designing your solution as opposed to the three separate blocks of code. This is a much smaller solution, and it is a little bit more understandable and clearer, where you have this as your main method and you call this sum method. Okay, a method is a collection of statements that are grouped together to perform a particular action. We have here the max method. Let's make it a little larger. All right, so the max method is going to receive two integers. It will be referred to as num1 and num2 inside this method. And here is the method body. And over here in, let's say, for instance, the main method, you will invoke the max method and pass it two arguments, x and y. X, I'm not too sure what x is. Let's say x is 1 and y is 2. Now the values 1 and 2 get passed into the max method, and they will be referred to in this method as num1 and num2. And the logic is pretty simple, is if num1 is greater than num2, then return num1, else we'll return num2. So it's returning the larger of the two integers that gets passed. This result gets passed back and replaces this method call. So in this case, it would be 2, and then the value 2 gets assigned into the integer variable z. Here's some terminology for you to understand. As I said earlier, the public static are two modifiers, which we will talk about later. The next is the return type value. In this case, it would be an integer that was getting returned from this method. The method name is max, and here is the formal parameter list. We have two parameters. They're separated by the comma. The first parameter is num1. It's of the type int, and the second parameter is num2. It's also of the type int. This inside the box is what's known as the method signature, and the method header is the entire piece all the way to the curly brace. And then inside the curly braces, the opening and the closing is the method body. I'm going to skip over that because I just went through it. Let's go take a look at an example. We'll use the max method as an example. All right, we're going to go ahead and run this, and it says the maximum between 5 and 2 is 5. So we've got a main method, and we are initializing I to be 5 and j to be 2. We'll invoke the max method, passing it I and j, so it will get the values I being 5 and j being 2. And down here is the max method. It's going to return an integer, and I and I and j, which are 5 and 2, now become num1 and num2. We declare a variable for our results, and if num1, which is 5, is greater than num2, we're going to take num1, which is 5, and return it back into results. Otherwise, num2, which is a 2, would get returned, but that's not the case. 5 is larger than 2. So result gets a 2, and it gets returned, and we now go back from whence we came, and where do we come from? Right here. And the 5, the larger of the two, gets replaced or replaces this section highlighted here. The integer 5 then gets assigned into this integer variable k, and now k will contain a 5. And this printout statement says the maximum between I, which is 5, and j, which is 2, is going to be the value k, which we assigned to be 5. So that's how a method is developed, and it's how it gets called and how the return value gets passed back into another method. In this case, it's the main method. And inside the main method, we're calling the max method. Okay, I'm going to quickly go through this because I just stepped through this. This is the trace of the method max invocation. Now it says here a return statement is required for a value returning method. The method shown below in A is logically correct, but it has a compilation error because the Java compiler thinks it's possible that this method does not return any value. So over in A we have an error, and over in B it's corrected. Essentially, this method, which is the sign method, is going to return an integer, and it's going to receive an integer. And in here, we're going to determine what the sign is. Well, n, if n is greater than 0, we're going to return a positive 1. Else, if n is equivalent to 0, we're going to return a 0. Now, this else if n is less than 0, returning a -1 will generate a compiling error. You really do not need this else if section here highlighted in yellow. All you really need to do is remove the highlighted yellow and just say else return -1, which is what's over here. Because the compiler thinks that there could be another condition where this if clause yields a false, and it cannot. It's always going to be, if it's not positive and if it's not neutral, it's got to be negative. So you need to remove this highlighted if. Now, one of the benefits of methods is for reuse. The max method can be invoked from any class besides testmax. If you create a new class called test, you can invoke the max method using classname.methodName, for instance, testmax.max. So many methods are developed, and then they can be stored in a class called, let's say, testmax, and then to access that method, you need to reference the class name first, followed by a dot, and then followed by the method name. So this max method can be stored in a class called testmax and then invoked using this syntax. Okay, stacks. Here's an example of where things actually get stored. When you receive control, when your main method gets control from the Java virtual machine, an activation record is created, and it gets placed into what's known in storage in an area called the stack. If we go through our example where we invoke the max method from the main method, well, the main method created 3 variables, and they get stacked on top of one another, as do the activation records. So the first variable that got declared and initialized was I, and we have it represented here. Next, the variable j was declared and initialized to 2. Third, the variable k was declared but not initialized. We didn't know what that was. So in this activation record for the main method, we have these 3 variables. Then, as the code gets processed, it calls another method, the max method. When that happens, the max method creates another activation record stacked on top of the main method activation record. And here is where we pass the values 5 and 2 over to num1 and num2. The max method does its thing and passes back the 5 right here back over into K, and then this activation record for the max method goes away. It gets removed from the stack. And now the only remaining activation record is the main method activation record. And then once that main method relinquishes control back to the Java virtual machine, it will go ahead and get removed from the stack, and now the stack is empty. So that's the processing with methods. They get activation records, and those activation records get stacked on top of one another in the area in storage known as the stack. This is a trace on the call stack. I'm not going to spend too much time with it. I'm going to skip over it quickly because I just stepped you through that. But the next topic is the void method example. This type of method does not return a value. The method performs some actions. A void method must be a statement. For example, print grade 78.5. So the print grade method is going to have a void return type, and it must be in a standalone statement. Let's look at test void method. Okay, inside our main method, we're doing a printout and saying the grade is, and now it's a standalone statement. This is a void method. It has no return type. We're going to call print grade. We're passing it what looks to be a double. Let's go down to print grade, our method. Sure enough, we're receiving a double, and it's going to return nothing. So we're getting 78.5 into the variable called score. And now we're looking to see if 78.5 is greater than 90. That's false. We'll go to the next else. If 78.5 is greater than 80, that's false. Else if 78.5 is greater than 70, that's true. And we will print out the character C. We've already printed out the grade is, and then the only thing that's remaining is the actual grade for 78.5, and that will go ahead and print out the character C. And then we come to the end of here, and we return back to the original calling, returning nothing back, and there is no further instructions beyond the print grade call. So the program ends, the main method returns control. All right, so that's an example of a void method. Let's look at test return grade method. This is a little bit different. So the same solution with a different approach. All right, we have our same two printout statements, but in this case, we're going to go ahead and concatenate a new method call called getGrade, and we're passing it 78.5. Now, getGrade is a little bit different. GetGrade does have a return type. It's of the type char. It's going to be receiving a double. It will be referenced as score inside this method called getGrade, and 78.5 goes into score, and if 78.5 is greater than 90, that's false. Greater than 80, that's false. 78.5 is greater than 70, so it's going to return a C, and the C gets replaced with the C, so the printout statement is the grade is C. It will then do the next statement and pass a 59.5 to the getGrade method. Let's run that so we can see that the results are going to be the grade is C, and the next statement up here is going to generate the grade as F. And the 59.5 goes through the same logic, so now 59.5 is score. It comes all the way down through this if, else if, till it finally realizes that the only thing left after 60 is to return an F. And so F goes into here, and it will replace the get grade call with an F. And then the program ends. So that's a little different design of the same type of problem. This one is invoking a method that does have a return type. The other one was a void return type. Keep in mind that the void return type needs to be on a standalone line. It's a separate statement. You cannot assign anything because you're not getting any return type. So you couldn't go ahead and take the return type and assign it into another variable like we did earlier. I'm going to skip over this. I already did this. I don't know why we're going through this again. Next topic is passing parameters. We have a new print method called endPrintLine. And in this case, it's receiving two parameters. The first is message. It's of the type string. And the second is n, which is of the type int. It starts here, it ends there, and we've got a very quick for loop. It only has one statement that loops, and we're starting at I, and we're going to continue for as long as we go to n, whatever the n is that gets passed, and it will go ahead and print out the message, which is the string that got passed in the parameter list. Suppose you invoke the method using the following method call. What is the output? We have endPrintLine, welcome to Java, comma 5. This will print out welcome to Java 5 times. The next method call, which is endPrintLine, computer science, comma 15, will print out computer science 15 times. This last question, can you invoke the method using endPrintLine 15, comma computer science? The answer is no. It has to have the arguments must be of the same type in order, number, and compatible type as defined in the method signature. Compatible type means that you can pass an argument to a parameter without explicit casting, such as passing an int value argument to a double value parameter. So you can go ahead and pass an int to a double because that would be implicit casting and there is no precision loss. Passing an int to a double can clearly fit in a double. Passing an int, let's say 1 over to a double would be 1.0. So you've lost no precision. You cannot go the other way. You cannot go ahead and pass a double like 1.1 over to an int or 1.0 because now you're losing precision. And they must be in the same order and of the same compatible type. When you're passing parameters, there are two ways in which you can pass parameters. One is pass by value, and another one is pass by reference. In this chapter, we're going to talk about passing parameters by value. If the argument is a variable rather than a literal value, the value of the variable or a copy of the value is passed to the parameter. The original variable's value is not affected regardless of the changes made to the parameter inside the method. This program demonstrates passing values to methods. Let's look at test pass by value. Okay, we have two ints, num1 and num2, both being assigned 1 and 2, respectively. Now we do a print. I'm going to print this so we have it down below. Okay, so before invoking the swap method, num1 is whatever the value of num1, which would be 1, and num2 is num2, which would be 2. And sure enough, down here, it gets printed out. Num1 is 1, and num2 is 2. That's before invoking the swap method. Now we're going to invoke the swap method, and we're passing it num1, which is 1, and num2, which is 2. Let's go down to our swap method. And here's our swap method. We're going to return nothing, so this is a void method. And we are swapping num1, the value of num1, which is 1, and the value of num2, which is 2. And they will be those two values, so they're going to take a copy of those values, num1 and a copy of num1 and copy of num2. And so we'll put the value 1 in n1 and the value 2 in n2. Next, it tabs over and says inside the swap method, and then a couple of tabs, before swapping, n1 is going to be 1 and n2 is going to be 2. And that's right here. N1 is 1 and N2 is 2. Now we swap, and we all know that technique. In order to swap N1 and N2, we need to declare a temporary work variable called temp of the type int, and we'll go ahead and move N1, which is the 1, into temp, and then we'll take N2, which is a 2, and move it into N1, so now N1 has a 2, and then temp, which currently has a 1 value, is going to get placed into N2. So we've essentially swapped the two values. Now, at this point, N1 has a 2 in it, and N2 has a 1 in it. We print out, after swapping, N1 is N1, and N2 is N2. So after swapping, N1 contains a 2, and N2 contains a 1. We return back. We're done with this swap method. It started here and ends right here. We're now going to go back from whence we came, and it was at this point we do the next sequential instruction, and we're doing a print line on, after invoking the swap method, num1 is num1 and num2 is num2. They still remain 1 and 2. Num1 is 1 and num2 is 2. So regardless of what's going on inside the swap method, these values remain unchanged because they are passed by value, not by reference. If you wanted to pass something by reference, you're going to be passing the address of that particular item, and then inside the method, it's going to be referencing the address, which is the original place in storage, and those storage areas will be changed from that method call. But that'll be for another chapter, another topic. So for primitive types, num1 and num2 of the type int, these get passed down here by value. And here is how that would work using the activation records. I'm not going to go through that. Methods can be used, this is for modularizing code or coming up with smaller packets of code. Methods can be used to reduce redundant coding and enable code reuse. Redundant coding would be the very first example where we had the redundancy of the three ranges that we needed to print, 1 through 10, 20 to 10 to 20, and 25 to 35. Methods can also be used to modularize code and improve the quality of the program. Once you create a method, it can then be used by yourself over and over again. And as well, many of the people that you work with, your other programmers, can go ahead and use these methods once they have been fully tested and been installed into a production library. Then they can go ahead and be invoked from your program. So you don't have to rewrite these, what oftentimes can be a very complicated method. Let's look at the greatest common divisor method. Okay, we have, let's bring this down a bit. Make this a little larger. All right, we're getting scanner input, and we're going to ask the end user for a first integer. We'll put that in N1, and we're going to ask for a second integer. We're going to put that in N2. And we know what the greatest common divisor is. If I was to give you an example of, let's say, the greatest common divisor of 6 and 9, well, we can do the mental math and say that that greatest common divisor, the GCD, is going to be 3. So let's use these two as examples. N1 is going to have a 6, and N2 is going to have a 9. The greatest common divisor for N1, or 6, and N2, or 9, is we're doing a method call. The GCD method is being invoked, and we're passing it two parameters, N1 and N2, and we're going to pass, what are they? They're ints. So 6 is going to be N1, and 9 is going to be N2. They do not have to be the same names. As a matter of fact, I strongly suggest you come up with different names so you don't get confused between the N1 inside the main method and the N1 inside the GCD method. So we now have the GCD method down here using the same variable names, N1 and N2, both of the type ints. It will return back an int, presumably going to be the greatest common divisor. And here's our little tricky routine to figure out what is the greatest common divisor. We'll initialize the GCD to be 1 because 1 goes into everything. And we'll start K, which will eventually be a work variable that will determine the greatest common divisor. We'll start that with K. We'll start that with 1, excuse me. Now we've got a while loop that goes from here to there. And we're going to ask the question, if N1, which is 6, modulus K, K is 1, if that's equivalent to 0, and it will be because anything divided by 1 is going to have a remainder of 0, ANDed with N2, which is 9, modulus 1, equivalent to 0. So that also will be true because 9 modulus K will yield a 0 remainder. We have a true ANDed with another true, and that overall result will be true. So we do the next instruction inside here, and there is no curly braces, so the if block is only one statement, and we're going to assign K into the GCD. It's rather redundant because we initialize K to be 1, and now we're assigning 1 into GCD. Now we're going to increment K. So now K is 2. And we'll do K, if, well, K2 is less than N1, 6, and K, which is 2, is less than or equal to N2, which is 9. So that is true. And now we're going to ask if N1, which is 6, modulus 2, is equivalent to 0, and N2, which is 9, modulus 2, is equivalent to 0. The first part of this is true, but we're ANDing a false. 9 modulus K, or 9 modulus 2, is not equivalent to 0. We have a remainder of 1. So therefore, we don't do the loop, the if body, and we're going to skip over that condition when it's true, and we're just going to increment K to 3. While K is less than 6, that's true, and K is less than or equal to 9, That's true. Now we're going to do if 6 modulus 3 is equivalent to 0. That's true. ANDed with 9 modulus 3 is equivalent to 0. Those are both true. So we're going to go ahead and take k, which is 3, and assign that into GCD. This will continue looping up until the point where we get to 7, which is 1 more than the smaller of the two integers. And we're going to say, while 7 is less than or equal to n1, that's false. A false ANDed with this will be true. 7 is less than or equal to 9, but a false ANDed with a true is going to be an overall false. And we are going to get out of the while loop, and we're going to return the GCD. In our example, it will be 3. 3 gets returned back here, and this print statement will print out the greatest common divisor for 6 and 9 is going to be 3. So this is a method called the GCD. The point on this is that we have a main method, starts here, ends down here, and here is like your mainline logic. You're doing some, you're asking for 2 integers, and then we're calling a greatest common divisor method to print out whatever the result is. That mainline logic is rather straightforward. If I was to include this, I'll call it convoluted logic, in the mainline processing here, it would get very disguised and obscured as to what the mainline logic is doing. So it's a good idea to go ahead and create a method that many people can use. There may be a need for GCDs and other programs. So you might want to create a method called GCD, get it out of your mainline logic, and declare it and develop it down here inside this class called greatest common divisor method. Oops, sorry, let me get to this here. Okay, so I'm not going to go through the prime number method, but it's the same type of thing. To determine a prime number is somewhat complicated, and it's a rather creative solution. And I'll leave it up to you to go take a look at the prime number method. It's posted out there in Blackboard in the program section. And you can see that there is a separate method called the prime number method that the mainline logic calls, okay, in the main method. And you can step through to see exactly how this prime number method actually does ascertain whether or not an integer is a prime number or not. And it just gets passed back as a Boolean, I believe, true or false. So in this case, you know, it will determine if a prime number is a prime number. It's got to either be divisible by itself or 1, and that's it. And the prime number method determines that. Okay, write a method that converts a hexadecimal number into a decimal number. We've done every combination going, I think, up until now, except hexadecimal to decimal. So let's look at this code, hex to decimal. I will run this, and you'll see that if I enter a hex number, and I'll enter 1F, and the program comes back and says the decimal value for hex number 1F is 31. And I can mentally check that because I know that a 1F in hexadecimal is one group of 16 and F groups of 1. So I can go ahead and add those two. F is a value of 15. So I have one group of 16 and I have 15 groups of 1. 16 plus 15 is 31, so the program checks for a simple example. Let's see how it's constructed. We're getting scanner input, and I am going to enter my 1F into a string variable called hex. So my 1F now goes into the string variable hex. The next is a print statement. The decimal value for hex number 1F is, and now I am invoking the hexadecimal method on another method call. This particular method call is the toUpperCase method. Over in the string class, there is a toUpperCase instance method inside the string class that we now can invoke. We've created on an object. The object is hex, so I can now use the toUpperCase instance method in the string class on the hex object, and that will take my 1 and my lowercase f and flip it to uppercase F. So this method call will flip it to 1 uppercase F. And then this method call, hexadecimal, will work upon 1 uppercase F. Hexadecimal is right here. It's expecting a string. It's getting 1 uppercase F. And it's going to return an integer value, which is just what we want. We want the decimal value of 1F. Here's what goes on inside this, I'll call it complicated, hexadecimal method. We're initializing decimal value to be 0, and we're doing a for loop. And this for loop will go ahead and take hex character at 0, which is the 1, and assign it into hex char. It's of the type char. And now we're doing a decimal value times 16. Decimal value is 0, so it's going to be 0 plus hex char to decimal on hex char. So what is hex char? Hex char is 1, and that gets passed to hex char to decimal. That's this method down here. It's receiving the 1 character, and it asks the question, if CH, which is the character 1, is greater than A, and the character 1 is less than the character F, in other words, is the character 1 within the range of A and F? That is not the case, so that's false. We're not doing this return. We're going to go to this else, and we're going to return CH, which is the character 1 minus the character 0. And that's going to be the value of 1. So the value 1 is going to get returned from this evaluation, which is of the type int, and this now gets placed into here, and this whole thing is a 1, so 0 times 16, which is 0, plus 1, now gets assigned into decimal value. Decimal value contains a 1 in it, and we're not done. We're still going to go ahead and now bump I to be equal to 1. And we're going to go for as long as we have hit the length of the hex string that I entered. So it's only going to go one more time. This particular time, we're taking the character at 1, which is my F, and assigning that into the hex char. And then we're going to go ahead and do decimal value, which contains a 1 times 16. So that's going to be an overall 16, plus hex char to decimal on hex char, which is now uppercase F. This now gets put into the CH variable of type char, and it asks the question if CH, which is a character F, is between A and F, and in fact it is. We're going to return 10 plus the character F minus the character A. The character F minus the character A is an overall 5. It's a value 5. To go from A to F is to increment up 5 times. So we have a 5 plus 10 is going to be an overall 15 getting returned. 15 is of the type int, and it will come back to here, and I now have 15 replacing this expression. I have decimal value 1 times 16. That'll be a 16 plus 15. That's an overall 31 getting assigned into the decimal value variable right here. And we are done with our for loop. And the for loop will then return the value decimal value here. And we now come back up to the top, and we will replace this long expression with 31. And that is how this rather complicated hexadecimal method gets invoked. And it actually invokes 2 methods. It invokes the hexadecimal, and it also invokes the hex char to decimal value as well. Next topic is overloading methods. Overloading the max method. Here is the max method, and it receives 2 parameters. The first one is num1, it's of the type double, and the second parameter is num2, also of the type double. Now we know how this works, so let's look at test method overloading. In this particular case, we are printing out the maximum between 3 and 4 is, now we'll pass the 3 and 4, these are both integers, to the max method. If we look down here, we have 3 different max methods. This max method is going to work upon parameters that are strictly integers. This max method is going to work on strictly 2 doubles. And then the final one is going to work upon 3 parameters, all of the type double. So it has the same method name, but it has different return types and different parameter lists. Let's step through this code. The first one is going to be a method call using 2 integers, 3 and 4. Okay, that will use this first max method because it's going to try and match. And by the way, the method bodies can be different. But in this particular case, these 3 method bodies, the first 2 are identical. The third one is a little bit different. We'll get to that in a second. So this method call on 3 and 4, num1 is 3, num2 is 4. It will return the max num4. Num2 is going to be 4, and that will get returned back, and 4 will get in place of that. And here, whoops, the maximum between 3 and 4 is 4. The next method call, we're passing max 3.0 and 5.4. Those are 2 doubles. Well, it's not going to match up with this method signature that has 2 ints. It does match up with 2 doubles. So this is the method call. This is the method, the max method that will be used. And this will return the maximum of 3.0 and 5.4. And we're going to get this printed out using that method call. The next one is going to invoke the max method, and it's going to have 3 arguments. 3.0, 5.4, and 10.14. It will look to determine which max method matches, and we have here a double, and a double, all three getting passed. So num1, num2, and num3 will have 3.0, 5.4, and 10.14 respectively. And look what this does. This does a quick return on max, num1, num2, comma, num3. We'll work from the inside out. So this is the first method call, and it's going to return the maximum between num1 and num2. We're receiving two doubles for num1 and num2, so it will therefore use this method for the first invocation, and in this case it's going to return 5.4. Right here will get replaced with 5.4. Now we have max on 5.4, comma, num3. Num3 is 1014. That is also a call on two doubles, so it will return 10.14. So now we have 10.14 getting returned to here, and this will now get replaced with 10.14. So this is a rather tricky method overloading, where you're actually using another method with inside this method, both of the same name. And then last but not least is max call that we're calling 3, 5, and 10. Now it said it's of the compatible type, so we're doing integers here. So it's 3, 5, and 10. We can go ahead and invoke this max method because it requires 3 parameters, and although they are not ints, they are doubles. This is what's known as type widening, which is permitted, and we can now go ahead and follow the same process that I just stepped you through for the 3, 5, and 10 as if they were doubles. This would get converted over 3.0, 5.0, and 10.0, which is why the result comes out as a double 10.0. All right, so that's method overloading. Sometimes there may be 2 or more possible matches for an invocation of a method, but the compiler can't determine the most specific match. This is referred to as ambiguous invocation, and this becomes a compile error. I keep losing my mouse for some reason. I'm not too sure why, but all right, let's take a look at ambiguous overloading. I didn't do ambiguous overloading. I'll show you what this is in the PowerPoint. For instance, here, we are passing max1, comma 2. These are both ints. Well, it'll look to see what's the best match without explicit casting. Well, we have int num1, that corresponds with that, and double num2, well, that can be widened to be that, so this could be used. But by the same token, this max method down here could also be used, because this int can be widened to a double implicitly, as well as this 1 can be widened to a double, and this 2 can be maintained as an int. So it's confusing. It's confusing to the compiler, and this is what's known as an ambiguous invocation in attempting to overload. And you will get a compile error. You're going to need to fix that. Okay, this is a little bit of a review, I think, but we're going to go through it, and we'll talk about the scope of local variables. A local variable is a variable defined inside a method. Your main method has local variables in it. The scope of the local variable is the part of the program where the variable can be referenced. It's visible. You can actually take a look and see what's inside that area in storage. The scope of a local variable starts from its declaration and continues to the end of the block that contains the variable. A local variable must be declared before it can be used. You can declare a local variable with the same name multiple times in different non-nesting blocks in a method, but you cannot declare a local variable twice in nested blocks. Let's step through an example. What we have here is a public static void method 1. So inside this method, I am declaring an int variable called I, highlighted in this turquoise color. And the scope of this variable I starts from its declaration, and it will continue down to the bottom of this for loop inside this block. You cannot reference I outside this block, such as after this for loop or before the for loop. Here we have another int variable called J, and its declaration starts here, so its scope only goes from its point of declaration down to the bottom of the for loop. And you cannot reference I or J outside down in here, let's say. It is fine to declare I in two non-nesting blocks. Here we have X and Y inside the void method 1 block, and now we have an int I declared inside this for loop, and we have another for loop where we can go ahead and declare another I of type int. This is fine because these are not nested for loops. And we can also reference X inside this, because this is a nested block inside the method 1 block. We can reference X here. We do not need to declare it. We cannot declare it again. And likewise Y. It is wrong to declare I in two nesting blocks. Here we have I getting declared inside the method 2 block, and then we have another nested block where we are declaring I inside this for loop, and this is wrong. This is a nested for block inside the method 2 block, and this is not going to be permitted. This is a duplication of what I just said. And the next topic is method abstraction. You can think of a method body as a black box that contains the detailed implementation for the method. As I'm sure you've kind of concluded by now, the assignments are getting a little bit more and more challenging, and they get a little bit more complex. As you start to figure out solutioning and start to solution some of these complex problems, it's probably a wise idea to create a method so that it can be reused and the next person doesn't have to go through the same toil and rigors of creating a routine. They can just use your method. So methods lend themselves to be complex, and you test them every which way, and then you go ahead and put them in a class that can be invoked for other programs to use. So this method abstraction is a concept that essentially means programmers don't really need to know how the actual method works inside the method body. Their only real concern is what is the method header? What is the name of the method? And what are the arguments for input? And what's going to be returned back from the method call. Inside the method body, it could be very complex, convoluted code that nobody really is concerned about, other than the fact you want to be concerned that it works and it's been thoroughly tested. So it can be a black box, or it's known as method abstraction. Very much like abstract art is a good example. If you ever took a look at a painting by an artist that does abstract art, it's very hard and it's somewhat hidden as to what the real meaning of that piece of artwork is. Well, that's known as abstract art. The same concept can be applied to method abstraction, where it's rather hidden as to how the actual method accomplishes its task. All that's needed to be known is the header and the return value and what you need to input. The benefits of methods, well, write a method once and reuse it anywhere from anyone that has access to that library. It also provides information hiding. You can hide the implementation from the user. If you developed a rather complex method and you don't want other people to steal it from you, whether it's customers or other competitors, you can go ahead and hide the implementation and make it such that it cannot be stolen. And again, as I say, it reduces the complexity of your mainline logic, and therefore your overall complexity of your overall program. All right, here's a case in generating random characters. Random characters is a unique Unicode between 0 and hexadecimal 4Fs. A char data type is 2 bytes, so in 2 bytes you can handle up to 65K different types of characters, whether they are wingdings and smiley faces, or alpha, beta, pi, or the normal keys on a keyboard. We have way more than what we need to, than what we use, but there is a total of 65,535 different decimal values for character data. To generate a random character is to generate a random integer between 0 and 65K using the following formula. And I'll just skip right down to it here. You can call the math random method inside the math class, pass it this expression, and it will generate a random integer that will represent any character between, the values up to 65K. Now let us consider how to generate a random lowercase character. The Unicode for lowercase characters are consecutive integers starting with the Unicode value for lowercase a, and the Unicode value for lowercase a is a 97. Lowercase b would not be 98. Lowercase c is value 99, etc., all the way up to z. You can go ahead and express this in Java code as the character A surrounded by single quotes, and then cast it to an integer, and that will get cast to a 97, a value of 97. So a random integer between A and Z casted to integers is, and then here's the expression for that, where we're using characters to define our limits or our zone, and then casting things to integers. As discussed in Chapter 2, all numeric operators can be applied to the char operands. The char operand is cast into a number if the other operand is a number or a character. So the preceding expression on the previous slide can be simplified as follows. You can get rid of all that casting because it's done implicitly, and you can say lowercase a plus the math.random method, and then z minus a plus 1 will generate a lowercase random character. So a random lowercase letter now needs to be casted to a char, and now it becomes a letter, an actual character. So you take this expression here and put a casting of a char in front of it, and it will go ahead and create a lowercase character that is randomized. In summary, here is the formula. Between any two characters, where CH1 and CH2, CH1 being less than CH2, so you could do CH is A and CH2 is D, and you'll get random characters between A and D. Let's look at the test random character class. If we look at this here, we're going to see that inside this test random character .java file, there are two classes. There's the test random character class that starts there and ends there. It's got a main method. And then there is another class called random character. And inside this random character class, there are many different methods. Get random character, return a character, it gets passed characters. Get random lowercase character will return back a lowercase a to z. Get random uppercase letter will return the uppercase random uppercase a through z. Another method called get random digit character returns a random digit between 0 and 9. And then this get random character will go ahead and just return any random character between Unicode 0s all the way to Unicode Fs. So there are your many methods within inside this class called random character. A question that was brought up in another section of one of my classes said, why isn't this public? After all, every class up until now, we've had a modifier of public class test random character. And the answer is if you're going to put two classes within inside a .java file, Java only allows one of those classes to be public. Now, you can put multiple classes inside a file, but only one can be public. So this is just class, which means that it has no modifier, so that would mean that its modifier is the default package, which means it's addressable within this package, test random character, all in lowercase. Let's run this, and what this does is it will generate a whole bunch of random characters. And the number is going to be a total of 175 random characters, and we're going to print 25 random characters per line. Those are my constants declared right up top. And here are the 7 lines of 25 random characters totaling 175. We have a for loop. And this for loop starts at 0, and it's going to go for as long as it loops up until number of chars. Number of chars is 175, so it'll go for 175 loops. And we are going to call the get random lowercase letter method inside the random character class. That is visible because it's in the default package, and that means that it can be found right here inside this file. And sure enough, here is the random character class, and we have get random lowercase letter method inside there. It's right here. And we can go ahead and it will return. It's going to do some calling to other different methods. Here's get random character, and that can be found all here. But my point is that all of this gets removed. This is almost like method abstraction. We don't necessarily need to follow all of these returns for all these different char types. But what this is doing is it will handle all the different types of randomizing of characters, whether it's lowercase or uppercase or digits or just a general character. These methods will go ahead and accomplish all of that. And all you really need to be concerned about is the fact that this method call inside this class called random character will go ahead and generate lowercase characters, and then the rest is rather straightforward. We're starting I at 0, so we're going to add 1 to it. So if 1 modulus characters per line equals 0, that's not the case. 1 modulus 25 is not equivalent to 0. But when we get 24, the 25th loop, well, now 24 plus 1 is 25. Modulus 25 is equivalent to 0. Then we're going to start a new line. This has the print line method. If it's not evenly divisible by 25, we're just going to go ahead and do the system.out.print, which will append the random character to the end of the string. Whoops, stepwise refinement right here. The concept of method abstraction can be applied to the process of developing programs. When writing a very large program or a system of programs, you can use the divide and conquer strategy, also known as stepwise refinement, to decompose it into subproblems. The subproblems then can be further decomposed into smaller, more manageable problems. The book gives the example of printing a calendar. Let us use the print calendar example to demonstrate stepwise refinement. This is the actual problem. Let's say the customer wants a calendar printed, the calendar month, and you need to provide the year and the month. In this example, we are providing 2009 for the year, and the month is going to be April. And your program gets 2009 and 4, and then prints out this nice header, and it also determines which is the start day. It was a Wednesday. And the end day, we know that April has 30 days, and every April has 30 days, but not all months have the same number of days. So as you can see, this can be quite a complex solution. Using stepwise refinement, you can break this problem down into smaller and smaller and smaller parts. Here's the design diagram where we want to use a top-down approach. We need to print the calendar. So we're going to develop our mainline logic. First thing we need to do is read input, and then there's another process block over here to print the month. To print the month is going to require printing the month title and then printing the month body. Printing the month title, well, you're going to need to go ahead and transform the 4 over to the string April. So it'll be a process, a stepwise refinement so that we are able to get the month name of April. The month body, you're going to need to know what the start day is. In the case of April 2009, it started on a Wednesday. So that is another piece that's going to have to be written. That program, that method will have to be written. And then another method would be get number of days in the month. April has 30, December has 31. The tricky one is February, because February has 28 normally, but on leap years it has 29. So you're going to need to get the total number of days and put that into the total number of days per month and determine whether or not it's leap year. So as you can see, this design gets a little bit complex, and the way in which you can go ahead and implement this development is to use a top-down approach and come up with what's known as a skeleton for the print calendar. Let's look at the skeleton. Okay, here is the skeleton, and inside here is your main method, and you're asking for the year, and you're asking for the month. Our example, we're using 2009 and 4 for April. And here is a method call on print month, passing it year and month. Here is the method print month. It's receiving year and month. It is a void method. It's returning nothing, so it's going to continue its processing. And each one of these methods is basically what's known as a stub, because it doesn't yet have the actual fully developed code. It just is like a placeholder for when that code gets developed, tested, and ready to go. It can then be placed right inside these curly braces. So the first one is print month title, and that should be rather straightforward. No, there's nothing to run. This is a stub. So it does nothing. The next stub inside here is the print month body. That too doesn't have anything in here at all. The stub for get month name, it's going to return back a dummy value. We'll call it January. The get start day, well, we're going to go ahead and return just a 1. The 1 could mean Monday, the first day of the week. Next is going to be the get the total number of days. In our requirements gathering, we determined that this calendar program needs to be able to print months that go all the way back to 1800. So for this, that's a rather complicated problem, but for this stub, we're just going to put 10,000 as a placeholder. So we'll return 10,000 to be the total number of days. And then get number of days in a month, well, we'll just put a placeholder, a dummy value of 31 to be returned. And is leap year, we'll return a Boolean, and we'll just go ahead and put a dummy value of true in there. All of these are stubs, later to be filled with the developer's code. I can run this, and I can put in 2010 and March, and it doesn't do anything because there's no code in this. But yet it compiles and it runs, and now we just need the actual code for each of those methods. That is known as a top-down solution approach. There is another approach, the bottom-up approach, although I don't see much of an example of where that happens. All my experience has been with top-down solutioning. And the benefits of stepwise refinement is to make the program simpler, to reuse all of those methods. Clearly, you would want to be able to reuse is leap year. I would think that that would be used in an awful lot of programs. Easier developing, debugging, and testing when you use stepwise refinement, and better facilitating of teamwork, because in all likelihood, all of those stubs are being developed by different programmers, and they are all going to need to be able to talk and make sure that they are developing concurrently and using maybe the same variable names, and it promotes for good teamwork using stepwise refinement. And then finally, we'll show the print calendar in operation. I will run this, and I'll put in today's date, and the month is March, and it quickly printed out this month's calendar. March 2016 is nicely formatted. The start day was Tuesday. Today is March 30th, Wednesday. So it works. It's calculating correctly. Quickly going over the structure of this, you'll see that we used the skeletal approach with stubs, but now all the stubs are filled in. So we get the year, we get the month, and we call the print month, passing it year and month. Print month right here gets year and month and calls the print month title. Print month title getting year and month is right here. And here is we have a nice, neatly formatted print month title, which is down here. March 16th, March 2016. The only real confusing thing is it needs to get the month name. So in here, to get month name, we're passing it the 3, and it goes to another method, and it will determine how it gets the month name. I would think that would be a switch statement. No, it's right here. So get month name is a switch on 3, and it would come down to month name and pass back the March, and then make sure you issue the break statement. And so now March gets replaced in here along with the divider, and then the days of the week. And then as you can see, as we go through each one of these methods, they can be rather complex, but then again, many different people worked on this. And you can see how to print the month body, get start day. Here is the start day, for instance, for January 1st, 1800 is 3. So that might be Wednesday. They may have looked it up and said, okay, well now, how many days is today since January 1st, 1800? Well, get total number of days, passing it year and month, and then come down here. You got to determine if it's leap year or not. And if it's leap year, you're going to accumulate the total number of days by adding 366. Otherwise, you're going to be adding 365 to the total. And here are the other remaining stubs that have gotten filled in with all the different methods. And is leap year is a straight return. Is leap year is not as simple as just dividing the year by 4. There are considerations when you're working with the centuries when it's divisible by 400, and also if it's divisible by 100. And so we have if the year, for instance, year is 2016, is modulus 400 is equivalent to 0, or 2016 modulus 4 is equivalent to 0, and year 2016 modulus 100 is not equal to 0. That's the formula for determining leap year, and that will return either a true or false. In the case of 2016, it's going to return back a true. This year is a leap year. All right, so that is the print calendar. Complex assignments, complex program, broken apart using stepwise refinement, and then assigning each of these methods to different programmers depending upon their skills as to what they can handle and what they can't, and hopefully it all comes together and tests thoroughly in a very short amount of time. All right, I think that brings us to the end of the PowerPoint and the end of methods. Yep, that's it. Let's go to the participants. And we have Julio and Michael. You guys have been very patient. Are there any questions at this point on everything that's been covered in the methods chapter?
Pause the recording before you ask.
I'm sorry, one more time?
You got to pause the recording before you ask.
I'm not sure what you mean.
I said it. Pause the recording. Since you already recorded the whole PowerPoint and examples, you got to stop the recording before you tell us to ask some questions.
Okay, I can do that, okay, but I want to have other people that might want to listen to the recording benefit from your question and also an answer. So
I have a quick question, Professor.
Okay.
The void methods, you said to be used as a single statement, separate statement.
Yes.
Can we do the same with a method that returns something if for any reason the actual return of the method needs to be ignored? So will the compiler give us an error if we do something like that?
Yeah, well, it's not going to know where if you're returning an int, it needs to now get placed into something. So if your return is an int and you get a 7 calculated, that 7 is going to need to be placed in a statement of some sort or get assigned into another variable.
But if we use it as a standalone, so basically ignoring the return, will it compile?
I don't believe it will. Okay, because it's got something. Go ahead.
That would be a logic error. You know, if by mistake one places a method that returns something, maybe mistakenly thinking that it's a void method, and so the compiler will recognize it, you're saying?
Yes, I believe it will. I'd have to test it, but my inclination is to say yes, the compiler's not going to like that. I know you can issue a return statement from a void method, but not returning a value.
Okay. So
all
just
right,
a return statement has to go back to the main program.
That's right. So you're returning control, but you're not passing any value, whether it's an int, a double, or a string, or a Boolean, or whatever. It's just returning control back from whence it came, and it will go to the next sequential instruction.
Okay. All right.
All right. Okay, but no values.
Okay. Yep.
Okay. All right. Thank you, Julio. Good question. Any other questions?
Not from me.
No. Okay. I mean, Michael, do you have a question that you would like to ask that's not recorded? If so, I can stop the recording now. And
about what you said earlier, the loops lab assignment. Well, even though you said it's optional, right?
Yeah.
Oh, I decided not to do it then.
Okay. I mean, as I say, that's optional. It's your choice.
Yeah.
Any other questions?
No, not from me.
Okay, Michael, you're all set?
Yep.
Excellent. Great. All right, gentlemen, thank you very much for your patience. It was a long one tonight. Hopefully it was beneficial, and we'll call it a night. And the next webinar will be at the end of the arrays chapter on chapter 7. Thanks again for participating, and guys, have a good night.
Thank you, Professor. You too.
Thank you.
Thank you.
Bye-bye.
All right, the webinar disclaimer. This WebEx service includes a feature that allows audio on any documents and other materials exchanged or viewed during the session to be recorded. By joining this session, you automatically consent to such recordings. If you do not consent to the recording, please do not join or participate in the session. This WebEx's service is intended to supplement the classroom experience. Duplication or redistribution of lecture capture recordings is prohibited without appropriate consent. Okay, where I'm going to resume from the last WebEx is on this concept called pass by value. I'll read the slide, and then if we want to discuss it, we can. Java uses pass by value to pass arguments to a method. There are important differences between passing a value of variables of primitive data types and passing arrays. For a parameter of a primitive type, such as int or double or short or long, the actual value is passed. You can conceive of it as if you are passing a copy of what was in the primitive type area in storage. Changing the value of the local parameter inside the method does not affect the value of the variable outside the method, because you're passing it a copy. For a parameter of an array type, the value of the parameter contains a reference to an array. This reference is passed to the method. Any changes to the array that occur inside the method body will affect the original array that was passed as the argument. So I'd like to go through a simple example here over in NetBeans. And it is right here. We have a simple example. We got a main method. We are initializing x to be 1, and we're creating an array of ints. The reference variable name is going to be y, and it is of length 10. First thing we're doing in this main method is we're invoking the m method, and we're passing it two parameters, x and y. X contains a value of 1. It's of the type int. And y is an array of ints. So the first parameter is an int, and the second parameter is an array of ints. Over here in the m method, it's expecting an int initially, followed by an array of ints. Inside the m method, we'll refer to the array as numbers. We will assign 1001 to the variable. This is a primitive type now. Int is a primitive type, and we're going to assign 1001 to the primitive int type number. Then we assign 5555 into the first element in the numbers array, keeping in mind that when we passed when we passed y to the m method, we are passing the reference variable name, which means we are now referencing back to the original array up here. And anything we do down here will affect the original array in the main method, referred to in the main method. Running this, we'll see that we invoke the m method, and then when we come back from the m method, x is going to be whatever the value of x is, and y sub 0 is going to be whatever the value of y sub 0 is. And we see x is still 1, even though in our called method we assigned 1001 to number, but that doesn't have any bearing upon this variable x. X is still 1. However, when we call the m method and we pass the reference variable to the y array here, now when we assign 5555 into numbers sub 0, we're really assigning 5555 into the original array, and therefore y sub 0 will be 5555. Prior to that, when we created the y array, it by default gets initialized to zeros, integer zeros. And in the m method, we overlay the default 0 with 5555. So the important concept is to understand that when you pass an array as a parameter or as an argument, such as in here, we're receiving this, and this y is an array, anything done to that array will be done to the original array. Anything done to this primitive type will be done to the copy, which is whatever number is. It's a copy. So when we invoke the M method and we pass it x and y, the values of x and y are passed to the number and numbers, the corresponding variables in the M method. Since y contains the reference value to the array, numbers now contains the same reference value as to the same array. In looking at this in the stack, we do know that when you enter your main method, an activation record gets created inside the stack. So this box down here gets created, and the local variables of that method get stored in the activation record on the stack. What was the first variable? X, and it was initialized to 1. The second variable was an array of ints called y. This is a reference variable to an array. The array is not stored in the stack. The array is stored over in another area of storage called the heap. So this reference, it's a pointer that points over to the heap area in storage, which is where the array is stored. Then we invoke the M method, and that creates yet another activation record on top of the activation record for the main method, and that gets stored in the stack. And the first variable that gets stored is the number variable of type int. This gets passed in through the 1 into number. And then the second variable is an array of ints, and it's being referred to as numbers. And that comes in as a reference variable. So that's a reference, an address that gets passed over to this activation record, which in fact points over to the same area and storage in the heap. Therefore, anything done to this numbers array is really going to affect the original array referred to as y in the main method. Let's take a look at test pass array. Okay, we're going to go ahead and run this so we can see what the output looks like. And it says, before invoking the swap, the array is 1, 2. After invoking the swap, the array is 1, 2. Before invoking swap first to in array, the array is 1, 2. And then lastly, after invoking the swap first to in array, the array becomes 2, 1. So let's look at the code. We have a main method, and we are declaring and creating and initializing an array of ints. It's going to be of length 2, and the array is 1, 2. So a sub 0 contains the value 1, and a sub 1 contains the value of 2. So it says here we're going to swap elements using the swap method. Before invoking the swap, the array is a sub 0 and a sub 1, and that's where we get this output right here. Array is 1 and 2. That's before the swap. Now we're going to invoke the swap method, and we're passing it 2 arguments. The first argument is the first element in the array, And the second argument is the second element in the array. Now, we're not passing arrays. We are actually passing ints. We are passing the element, not the array. And the element is of type int. So we'll look at the swap array. And in fact, it is looking for 2 ints. Inside the swap method, it will be referred to as N1 and N2. And these 3 lines of code will take whatever's in N1 and put it in N2, and take whatever's in N2 and put it in N1. So it's swapping. It's a void method, so nothing gets returned. And when we come back to the swap method, passing it those 2 elements, we now report out, after invoking the swap, array is array sub 0 and array sub 1. And in fact, after invoking the swap, the array is still intact. It is array is 1 and 2. Nothing occurred to the original array. Even though we passed 2 elements in the array, we are not passing the reference variable of the array. So the original array is unaffected. Now we're going to swap the elements using the swap first 2 in array method. Before invoking the swap first 2 in the array method, we have array sub 0 and array sub 1, and that's reported down here. Now we're going to invoke swap first 2 in array, but what are we passing it? We're passing it an array. Its reference variable name is A. So this is a pointer. Beware, whatever we do in this method is now going to affect the original array up here. Down here is the method swap first 2 in array. It's receiving an array of integers. Hereafter, in this method, it will be referred to as array, and we're doing the same swap method, storing the first element to a temporary variable, then taking the second element, putting it into the first, and taking the temp and putting it into the second. And that just basically flip-flops the elements in the array. It is a void method, so nothing is being returned. However, we have changed that area in storage that is referenced using the reference variable A. So now, after invoking the swap first 2 in array, we are now going to print out A sub 0 and A sub 1, and you'll see that, yes, in fact, the 2 elements have been swapped. So keep that in mind as you're passing arrays as arguments to other methods. You're passing a reference variable, not a primitive type, which will pass the value. One is passed by reference, and the other one is passed by value. If anybody has any questions, just speak right up. Otherwise, I'm going to keep going. Let's see who joined, just to welcome the folks. We lost a few. We gained a few. We lost a few. So we still have Leah and Michael. I'm going to skip over this example, but it's essentially the same thing, keeping in mind that the stack is what stores the local variables for methods and the activation records, and they get stacked on top of one another in a LIFO, or last in, first out method or procedure. And the arrays are stored, objects are stored in the heap. And those are stored in an arbitrary fashion. And when the method is no longer processing and it returns back to the previous method, the activation record in the stack goes away until you eventually go down to the main method here. So for instance, this swap method, its activation record will go away once it returns back to the main method. And then when the main method is done processing, it gets removed from the stack as well. The heap, on the other hand, these areas in storage will be monitored by the Java virtual machine to determine whether or not any method is pointing to these objects. If nothing is pointing to an array object, the JVM will determine that, and through a process known as garbage collection, it will remove those areas in storage, and will free up that area in storage for use by other programs. Okay, next is returning an array from a method. And what we're going to do is we're going to use the reverse method to take a closer look at that. I'm going to run that. And as you can see, the output basically lists the first array as being 1, 2, 3, 4, 5, 6, and then the second list is going to be 6, 5, 4, 3, 2, 1. So it takes the first array and reverses it. Here where we're declaring, creating, initializing list 1 to be of 6 integers, and then we are invoking the reverse method on list 1, and we're going to assign the results into a list 2 array of integers. Reverse method is right here. It's expecting to receive an array of integers, and essentially what this does, it uses 2 pointers where we're going to store the result in a list in an array of integers, and result will be the same length as the list that it was passed. And we are using a for loop. We're setting I equal to 0, and j is going to be equal to the length of the array minus 1. So we're pointing to the index, the last index, using j, and we're pointing to the first index using I. We'll loop for as long as the list is long, and we're incrementing I, and we're decrementing j. And we're taking the first element in the array and assigning it into the last element into the result array. And then we loop again, incrementing I. So this will now take the second element and assign that into the second to last element in j. Incrementing I and decrementing j all the way through the loop, you'll see that results now will contain the reversal of the original list 1. And that is what the results are here. So what we're doing now is we are returning an integer array denoted right here in the return type. Then you can take that array and assign it into a similar type, data type array, such as what we did here using list 2, and then we print it out. This is nothing more than the quick for loop to print out an array, and we print them both out, and you'll see that they're reversed. I'm not going to trace the reverse method. We just kind of did that, but you could take a closer look at that to see that these elements are now going into the result array in a reverse way. I'm going to skip over the count letters in array because it's more of the same. And I'll talk about searching arrays. Searching is the process of looking for a specific element in an array, for example, discovering whether a certain score is included in a list of scores. Searching is a common task done in programming, and there are many algorithms and data structures devoted to searching, one trying to be more efficient than the next. In this section, two commonly used approaches are discussed, the linear search and the binary search. The linear search approach compares the key element, called key, sequentially with each element in the array, called list. The method continues to do so until the key matches an element in the list, or the list is exhausted without the match being found. If a match is made, the linear search returns the index of the element in the array that matches the key. If no match is found, the search will return -1. Let's look at test linear search. First thing to note here is that there are two files. Test linear search, which is the class that will contain the main method. Usually the test that contains the main method is prefixed with the word test, and then the second part of the class name is going to be the class name that it's going to test. In this case, it's linear search. And linear search looks like this. This is a class. It does not have a main method in it. It just has another method, but not a main method. The linear search method is going to return an integer. The integer will either be the index of where the key was found, or it will return -1, which means that the key was not found in the list. And this is the for loop that does that. If the key is equivalent to list sub I, we return I. We'll keep looping. And if you eventually do not find the key, it's going to return -1. The test linear search looks like this. Inside is its main method. And we have an array of integers initialized to 1, 2, 3, 4. The target, or the key, is assigned the value 3. We can then use linear search, which is the name of the class, right here, inside this default package called test linear search. So we can address this. This has visibility. And inside this linear search class is a method called linear search. Here's your linear search class, and here is your linear search method. We're passing it array and target, declared up here, array and target. So the array is the first argument, and an int is the second argument. Over here, it corresponds. We're going to get an array of ints. Hereafter, it will be referred to as list, and the second argument is going to be key. And we'll reference and we'll loop through to see if, in fact, the key is inside the array called list, and return the appropriate int value. Running this, it comes back and it finds the target 3 and was found in element 2. A 2 was returned back into result, and if result is equivalent to -1, then we say the target was not found, the target 3. Else, if it's not -1, well, then we actually have where the element was found, where the key was found, which element. So in this case, the target 3 was found in element, and whatever the result was, element 2. And here is element 0, here is element 1, and here is element 2. This is the structure that we should start using for when we start to define and develop classes, such as linear search. Linear search is kind of a commonly done thing, so it's probably a good idea to create its own Java class, Java file, and then reference it. And now it can be referenced in many different, from many different programs elsewhere in other packages. And the way to do that is to call it linear search, call it the class name, and then to test it, create yet a different file called test linear search, which includes the main method. Skipping over this animation, we'll now talk about the binary search. For a binary search to work, however, the elements in the array must already be ordered. In other words, an ascending sort must be done on an unordered list in order for us to perform a binary search. Assume for a moment that it is in ascending order and the array looks something like this. The binary search first compares the key with the element in the middle of the array. We have an array, and it looks as though the middle is somewhere in the middle here, and it will look to see if the key is equal to, what do we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the middle would be like 6. 1, 2, 3, 4, 5, 6. Is that it right here? And it'll look to see whether or not it is in the middle, and if it's equal, well, then we found the key. Or we could return back and say it's lower or it's higher. And then in so doing, we're going to start splitting the array into halves and eventually narrow it down such that it will eventually hit the key in that style. Let's go through binary search. Okay, once again, we have our test class, and we have our binary search class. Over here, we have our main method, where we declare and create and initialize an array. I have it as 1, 2, 3, 4, 5, 6, 7, 8. So this has been sorted in ascending order. And the target is 9. And I can take a look to see that, yes, in fact, it's right here. So we will now invoke from the binary search class over here the binary search method inside that class, passing it array, which is an array of integers, and also a target, the target being 9 of the type int. Now the binary search method takes control, and this is the technique in which you can go ahead and do the binary search. You initialize a variable low to be 0. That's going to be element 0, index 0. And while high is equal to list.length minus 1, so now we're going to go ahead and point to how many elements were in this array? There was 11. 1, 2, 3, 4, 5, 6. There's no 7. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 10 elements in the array. We're looking for key 9. So the list length is 10. 10 minus 1 is 9. So the high index will be 9. The low index will be 0. Well, high, which is 9, is greater than low. That's going to be the case. 9 is greater than or equal to 0. we're going to calculate the midpoint to be equal to the low plus high, in other words, 0 plus 9, which is 9, divided by 2, integer division, is going to be 4. So mid will be assigned 4. And then we look to see if the key is less than the list sub 4, the one in the middle. If that is indeed the case, then what we're going to do is we're going to subtract 1 from the mid and reestablish a new high point. Else, if the key is equivalent to the mid, well, then we return it. We return the index where we found the key. Otherwise, we establish a new low, which is going to be 1 more than the current mid. So we add 1 to mid, and that would be 5. And then we would search for the key between index 5 and 9. And this will continue on. We'll loop this way, and you'll either find it or you'll return a, this particular expression is the evaluation of where the index, what the appropriate index should be in the event you wanted to insert this 9 into this array. So let's run this. So the target was 9 was found in element 8. Let's do a different one where we do 7, because it's not here. Running that, it says the target was not found. It would be inserted as element 7. So 0, 1, 2, 3, 4, 5, 6. It would be inserted right in here. This as element 7 is the expression negative low minus 1 which is this expression here. We take the absolute value, the negative means it wasn't found, and then we take what the result is, plus 1, and make it an absolute value, make it a positive number. And that's where you get element 7. So that's how you would test the binary search. Here is another example. Let's say we have key is going to be 11, and we have this array. And it has a total of 13 elements going from 0 to 12. We first identify or determine where is our midpoint. Well, our midpoint is going to be equal to the low index plus the high index, that's 0 plus 12, divided by 2. Integer division is going to be 6. So the midpoint is 6. And we ask, is the key 11 equivalent to 50? In fact, it is lower. So we have to reestablish a new high, which is going to be 5, which is 1 less than the mid. Now we have a new high, which is 5, a new low, here it is down here, and the mid is going to be equal to the low plus the high, that's 0 plus 5, which is 5, divided by 2, integer division is going to be 2. It now establishes a new mid. It asks the question, the program asks the question, is the key 11 equal to 7? In fact, it is not, it is higher. So we have to now establish a new low. A new low is going to be 1 more than the mid. And we'll be here at element 3. And we have 3 plus 5 is 8. Integer division 2 is going to give you 4 as the mid. And is key 11 equal to the mid? Yes, in fact it is, so you return the 4, the index of where you found the key. This is essentially the same thing, but in this particular case, the key is not going to be found. So it will keep halving and establishing new lows and new highs and new mids. And once it realizes that 54 is not in this array, it gets determined when the high gets below the low. And when that phenomenon occurs, then we now know that the key is no longer, it's not in this array. And what you need to do is return back one less than the low as a negative number, and that will indicate where the key should be inserted in the event you need to do that. And that describes that. Thankfully, for all the binary searching that's needed to be done in data processing and computer science, since it's frequently used, Java provides several overloaded binary search methods for searching a key in an array of ints, of doubles, chars, short, long, float, strings, and you can use this. It's located in the java.util package, and it's in the arrays class. For example, the following code searches the keys in an array of numbers and an array of characters. So we have an array of ints, presumably, and you can do this and find a particular, let's say, 11 in this list just by invoking java.util, the arrays class, and the binary search method, passing it the array, reference variable name, and the 11, and it will return a 4, which is the index of where it was found. It also works for chars. So we're passing it chars, and we're searching for a T, and it does not find that, but it will return a negative number saying it wasn't found, and then the 4 is the insertion point is 3, so it returns, the return is -3 minus 1, or -4. And that's where the character T would be inserted. Again, the binary search requires that the array be pre-sorted in increasing order. So sorting arrays, like searching, is also a common task in computer programming. Many different algorithms have been developed for sorting. In this particular case, we're going to go ahead and look at the selection sort. Essentially, what the selection sort does, I'll read it from the top. The selection sort finds the smallest number in the list and places it first. Then it's locked in. Then it finds the smallest number remaining in the remaining leg of the array and places that second. And it continues on until the list contains only a single number. In this example here, it looks through the entire array and it says the smallest element is 1. So it will swap whatever's in the first element 2 with 1. Now we have 1 here and 2 over here. We have the remaining leg of the array, and we will look to swap the smallest element with this first pointer. And 2 gets swapped with 9. Now 9 is over here, and 2 is locked in place. The remaining leg of the array will look for the smallest integer and swap it with the first. And now we have 4 here and 5 there. And it continues on until you eventually wind up having a sorted array. That algorithm, that technique, is known as the selection sort. I'm going to skip over that. made this large. There we go. So here's the selection sort. Here's an example of what we just did, so I don't need to do that again. There is another algorithm called the bubble sort. And the bubble sort is a little bit different. We have an array called A, and we have 4 elements in the array. And what the bubble sort does is it points to the first element in the array and the second element in the array. And it asks the question, is the first element greater than the second element? If in fact it is, swap the 2. And then it'll go to the next 2 elements in the array and ask the same question. And if in fact it's greater, then swap the 2. So for example, we have 3 compared to 4. Is 3 greater than 4? False. We don't swap. We go to the next. Now we have 4 greater than 2. That's true. We swap them. So now 4 goes over here and 2 goes over here. Now we have 4 greater than 1. Yes, in fact it is. So we swap them. So now 4 gets placed in the last element in the array, and we do it again. And now 4 is locked in, and now we look to see, is 3 greater than 2? It is. We swap it. So now 2 is over here, and 3 is here. Now we ask the question, is 3 greater than 1? Yes, it is. Swap the 2. So 3 is over here, and 1 is over here. And 4 was already put in place. So now we have 3 and 4 both put in their respective positions in the sort. Then we look to see, is 2 greater than 1? Yes, it is. Swap it. And we wind up getting 1, 2, 3, 4. Now we have an ascending sorted array using the bubble sort algorithm. The third, and there are many different sort algorithms, but the 3 that we're going to focus on in this class is going to be the selection, the bubble, and the insertion sort. The insertion sort works similarly. What you do is you lock in the first element in the array, and then you look at the remaining leg of the array and where would this element 4 get placed? Where would it be inserted in the existing locked array? And in this case, it would be inserted after the 3. Now we have 3 and 4 locked into place, and we would go to the next element. And where would we need to insert that element? That would get inserted ahead of the 3. Now we have 2, 3, and 4 locked in place, and we would go ahead and look to see where this last element, value of 1, where that would be appropriately inserted, and that would in fact be inserted ahead of the 2. So what we did mentally gets translated over into Java code, and that is how you can sort an array using 3 different algorithms: the selection, the bubble, and the insertion sort. Again, fortunately for us, we don't have to do that. We don't have to write that code for every time we want to sort something. There is a sort method in the arrays class that we can use. Just access it using the java.util package and pass it an array, for instance, of numbers. Here's an array of doubles, and you can pass it, and it will return back the array in ascending sorted order. This also works for chars, and this sort method will go ahead, and because we're passing it a reference variable, the original array will be sorted. So you can use that array. We now know chars is sorted after invoking this sort method. As a side note, Java 8 provides arrays.parallel sort on a particular array called list that utilizes the multi-core processors in today's computers for much faster sorting. Clearly, that would be an appropriate usage for very, very large arrays in the hundreds of thousands or millions, the parallel sort method. There is another method, the toString method, in the arrays class that you can use to print out to return a string representing the list. Okay, the main method is just a regular method. We've discussed methods in Chapter 6, and we've discussed arrays in Chapter 7. And now we're going to look to see what has been going on inside these parentheses, which are the arguments that get passed to the main method. In public static void main, we have an array of strings, and its reference variable name is args in class A. First thing that we do is we declare and create and initialize a string array called strings, and we're populating it with New York, Boston, and Atlanta. Next, what we do is we invoke the B method. We invoke the main method in the B class, and we're passing it this array, the reference variable name called strings. Over here is the class B, and it too has a main method, but it is being passed an array of strings, New York, Boston, and Atlanta. So hereafter in this main method, it will be referred to as args. So args sub 0 is going to have New York in it. Args sub 1 is going to have Boston. And args sub 2 is going to have Atlanta. This for loop will go for the length of the args length. So it'll go for 3 loops and print out arg sub 0, New York, arg sub 1, Boston, and arg sub 2, Atlanta. Here is how you can go ahead and pass arguments to a main method as strings into a string array. To do that, for instance, in Lab 7, you're going to be asked to pass an argument to the main method in your Lab 7 main method. What you need to do is go up to Run, and then come down to Project Configuration, Customize. A dialog box will pop up, and select the Run category, and over here under Arguments, there is a character N. In this case, it's surrounded in quotes. It doesn't need to be if it's just one character, but if there are blanks or spaces in between, you would need to put it in quotes in order for it to be considered the first element in the array. So we're passing it an N in the main method in NetBeans, and that's how you would do it. Hit OK, and now this program will interrogate that argument that gets passed to it, the N, to see what it needs to do. If you were to invoke this program using the command prompt, this test main, where we have a main method, public static void main, with a string array called args, you could, in the command prompt, you could invoke the test main method, the test main class, and pass it the arguments arg0, arg1, arg2, all the way up to argn by just separating them by blanks, and your program will interrogate those arguments. Let's look at the calculator exec, which will demonstrate this. The calculator program, its objective is to perform binary operations on integers. The program receives 3 parameters, an operator and 2 integers. So the operator is the plus sign, the minus, the division, and that should be an asterisk there. If you were to be invoking this on the command prompt, you would type in Java to kick off the Java virtual machine, and then the calculator passing it the 3 parameters. Over here, I'll make this larger, and I'm going to go to Run, Set Project Configuration, Customize, and this dialog box pops up. I'll make sure I select the Run category, and I know it's small, but it says under the Arguments box, it says double quote 6 space asterisk space 3 close double quote. Or in other words, it's a string of 6 times 3. That is what's going to get passed to this main method. I'm going to run this, and you'll see that the results are 6 times 3 equals 18. So it calculates. Skipping over these comments, the first thing that gets checked is to see if the args.length is not equal to 1. Remember, I put in 6 times 3 with the spaces and the double quotes. So the double quotes indicates that it is 1 argument. It's a string. It's an element 0 of the args string array is going to be 6 blank asterisk blank 3. That's the very first element, element 0. If the length is not equal to 1, then we haven't done things properly. So this if will generate, if it's true, an error message, and your program will end with a system.exit with a return code 0. But if the argument length is 1, then what we need to do is establish a field to store the result of the arithmetic calculation called result. And the next thing that we need to do is we need to parse or break up the argument that got passed. And it resides in element 0. There's only one element in this array. It's argument args sub 0, and inside that area of storage is a string that is 6 blank asterisk blank 3. We need to split that on the blanks and create another string array of tokens. And the tokens will represent, in token sub 0 will be the 6, token sub 1 will be the asterisk, and token sub 2 will be the 3. Now we're looking at token sub 1, so that will be the operator, and that's going to be either the plus, the minus, the asterisk, or the forward slash. Character at 0, so it's the first character. There's only one character, so it's going to look to see if it is a plus. It is not. Is it a minus? It is not. It is an asterisk. That's this asterisk here. And we are going to invoke the parseInt method from the integer wrapper class, and we are going to pass it token sub 0. It will pass it the 6. And we're going to multiply the 6 times the results of what gets passed to the parseInt method in the integer wrapper class for token sub 2. And token sub 2 is going to contain the 3. So we're essentially multiplying 6 times 3, storing it into the area called results, and then we break. Down here, we put out token sub 0, which is going to be 6, followed by a space, followed by token sub 1, which is the operator, which is the multiplication sign, followed by a blank, followed by token sub 2, which is going to be the 3, and we're going to follow that up with equals and the results, which would be 18. All right, so that is passing arguments to a main method. And that brings us to the end of the arrays chapter. Let's see who is here, and if anybody has any questions. I just see Leah and Michael. Are there any questions? Otherwise, we can call it a night.
About the arrays, isn't it possible to put multiple arrays in one class, or it has to be good with multiple classes in different projects?
Well, you can put multiple arrays in multiple methods in multiple classes. Okay,
no,
so
I mean, isn't it supposed to be like multiple classes in one, or it has to be separate?
I'm not sure I'm following your question, but for instance, are you looking
like the
at
in-class of 7A?
Okay.
Yeah, I mean, isn't it supposed to be like like instead of using 3 different arrays and 3 different sections, what if it should have been like all in one instead? But then for package, though, public class.
All right, well, in class 7A, we had one package. It was called in class 07A, and we had 3 .java files.
Yeah,
right?
that's what I meant. What if the Java file is supposed to be all in one instead of 3 different Java files?
You can go ahead and put them all into one file called .java file and put multiple classes in that one Java file.
Oh.
But it can only have one main method.
I mean, what if I would have thought multiple main methods, or it can't do that?
Not in one Java file, no.
Oh, that's what I was about to ask. Okay.
Okay, that's the reason why we created 3 separate .java files for in class 7, and each one of those separate .java files, those source files, had its own main method.
Okay.
Okay, but you're not restricted in the amount of arrays that you put into those. You can put in as many arrays as you want. Okay, good question, Mike. Any other questions, Mike or Leah? Okay, go ahead. What do you have, Leah? Did you have anything?
No, I just wanted to say thank you.
Oh, you're welcome. Glad to have you. Hopefully this was helpful, and I kind of go through things kind of quickly, but it's being recorded, so you can always go back and pause it and play with it and go back and redo it. And if you have any questions, you can always go to the discussion tool and ask questions in there. If there are no further questions, I'll go ahead and call it a night. Okay, so thank you both for participating, and we'll see you in class next week. Last class, we talked about this particular initial problem where we want to read 100 numbers and compute their average, which is simple enough using a for loop. Then the little hitch to this was finding out how many numbers are above the average. And that got to be a little bit more challenging, and the way to solve that is using arrays. We went through a bunch of utilities. I'll just quickly go back to the slide that identified them. Go through this. Here we go. In excuse me, in your needs to process arrays, here are some examples of code in which you can use to do the following functions. you need to initialize arrays with input values, if you need to initialize arrays with random values to be able to print an array, sum all the elements, find the largest element, find the smallest element, and then random shuffling and then shifting of the elements. These are all tools that can come in handy if you have an assignment that requires doing these activities. And so there are examples of all of these, and they're all out in Blackboard. I did give an in-class assignment that exercises those skills. Before I begin, did anybody have any difficulties with those, with the in-class assignment, or any confusion?
There was one thing that I got confused at near the end, but it was really just a minor typo issue on the visual logic.
What was the typo? I'd like to know what it was so I can fix it.
You said that the first part had to be I-1. I found out that that actually does not work. It needs to just be I, because the negative number is not actually put into the array.
Matt, I saw your point. I saw the point that you brought up in the discussion tool, and you copied your code in, and I did see that you were continuing your for loop for as long as I was less than 0. And
yeah, I changed that as you said, and later on, and I had gotten a different problem, and when I changed it, and that one was because I had made it I equals the entire length of the array minus 1, so I had changed that to I-1, and when I tested it again, it would cut out precisely one of the positive numbers. When I changed it to just I, it works just fine.
Okay, that's great. I mean, yeah, it all depends upon, you have to understand this key concept, and that is arrays are 0-based, which means the first element in the array is array sub 0. And you're going to have that off by 1 condition occurring, and the only solution that I can strongly suggest you do is to test your arrays thoroughly with all different test data, and make sure that when you come out of your loop processing your array, you need to find out what I is at that point in time, because everyone's logic is different. I could be the length of the array, it could be the length of the array plus 1, or some number off by 1. You can go ahead and do a system.out.println line and display I to find out what it is, and then if it's 1 too many, just subtract 1 from it. Or you can go into your for loop header and then adjust your continuation clause as you see fit. Were there any other problems with the in-class assignment? Okay, so then let's get to another slide or another concept. And I'm not going to go through the painstaking details of this particular program. Many programs are posted in Blackboard. You can take a closer look at how these are constructed. But here is a general description of a game that you might want to use or develop. It's a deck of cards. And then once you understand how a deck of cards can be represented using arrays, that you can come up with whatever games you choose. The problem is to write a program that picks 4 cards randomly from a deck of 52 cards. All the cards can be represented using an array named deck filled with initial values 0 to 51. Here's the code that would do that. This is declaring an array of integers. The reference variable name is deck, and this creates the object, this new keyword, and it will have 52 elements. The elements shall be named deck sub 0 up through deck sub 51. Now, to initialize the call, this deck of 52, start with I equal to 0, go for as long as deck.length, whatever that is, that's 52, and you're doing it all the way up to 51, so it'll go from 0 to 51 as you increment I. And you're putting 0 into deck sub 0, 1 into deck sub 1, all the way up to 51 into deck sub 51. If you want to visualize this, this is what it would look like. The scheme is that you've got 4 suits: spades, hearts, diamonds, and clubs. There are 13 cards in each suit. Each card can be thought of as 0 through 12 for the 13 spades, 13 through 25 for the 13 hearts, 26 through 38 for the 13 diamonds, and then 39 through 51 for the 13 clubs. The array would look something similar to this. So the deck element 0 would have a 0 as its value, all the way down to element 51 having a value of 51 in that element. Now, to translate this array over into an actual deck of cards, you can use the modulus function together with integer division to come up with the actual suit and displacement into that suit. For instance, card number 6. So we've shuffled the deck. Okay, so we did that random shuffle, which will shuffle the deck, and you can look to see that utility in the slides that I just referenced a minute or two ago for random shuffling. So now we have a random shuffled deck, and element 0 has the number or value 6 in there. Well, card number 6 is the 7 of spades, because 6, which is this value 6, modulus 13, is going to retrieve the remainder, which is going to be a remainder of 6. So that will be the 7th card of spades, because the spades is, you're going to take 7, integer division 13, and that's going to be the first group, which is group 0. If this is group 0, this is group 1, group 2, and group 3. So this little technique is going to get you the 7 of spades. The next card, which is in the second element in the array, or deck sub 1, has a value of 48 in it. This 48 can be translated over into the 10, which is 48 modulus 13. That's going to leave a remainder of 9. So it's going to be the 10th card, or the 10 of clubs, because 48, this number here, integer division 13, is going to be 3. So that will be the 4th group. This is group 0, 1, 2. So this is the 4th group down. And you can see now how they've created a way in which you can now play cards or have card games or card tricks developed as a programmer using an array and displacement into that array to determine the suit and then the card within that suit. Here it is in more graphic detail. This will introduce, for later courses, actually, a way in which you can develop more robust applications. And once you start using graphical user interfaces, you can take the backbone or the core of what we just discussed and apply it to, you could use images to represent each of the cards in a deck, and build a graphical user interface, something similar to this, where you have a dialog box and a bunch of elements within, including images of each of those cards that are represented behind the scenes in your Java program. And then they discuss going into some run 24-point game, which you can follow the logic of. This next one is rather complicated. It's called Lotto numbers, and I'll leave it up to you because it's lengthy on how to go ahead and create a lottery game. We'll go past that. Now, you're going to have a need to copy arrays because you do not want to clobber or destroy your first array in working with another array. If you need to copy an array so that you keep your first array intact, there are many ways to do it. There's 3 ways. Actually, we're going to just discuss 2. One way to do it is to use the assignment statement as follows. Well, actually using a for loop. But before we do that, let's take a look at what this assignment does. Let's say you have 2 arrays, list 2 and list 1. Currently, right now, you'd think that you could go ahead and assign list 1 into list 2, or list 2 equals list 1, when in fact what this is really doing, before the assignment, you have 2 arrays in memory. List 1 is a reference variable, which means it's a pointer. It's pointing to another area in storage. The storage area is called the heap, in which this array is stored. So list 1 has a reference variable pointer pointing over to another area in storage that actually contains the contents of that array called list 1. There is another array called list 2. And list 2 has a reference variable, a pointer, pointing to another area in storage that contains the actual array of elements for list 2. When you do this assignment statement, list 1 or list 2 equals list 1, that's really an assignment statement. That's not equating the 2 of them. It's taking this reference variable in list 1 and putting it into list 2. And when you do that, list 2 now points to list 1, as is described over here. So after the assignment statement, list 2 will now be pointing to the same area in storage as list 1. In other words, both pointers are pointing to only one array. And that's really not what you want to do. Because what happens is when you lose the pointer to list 2, as we've described right here, this is what's called garbage. And the Java virtual machine will recognize that nothing is pointing to this array and remove it from memory. So you will no longer have access to this. So this is not the way in which you should go ahead and attempt to copy an array. One of the easy ways to copy an array is to use a loop. For instance, right here we are declaring an array of integers. The reference variable name is source array. Equals, and now we're actually initializing this array all in one fell swoop here with one statement. So this is getting declared and created. In one statement. So we have a list of integers, an array source called source array, pointing to the array that has 2, 3, 1, 5, and 10 in that array. Now we're declaring another array called target array. It's of the type integers, int, and now we are creating that array, and we're creating it the same length as the source array. We'll use a quick for loop to go ahead and declare I as an int, setting it equal to 0, and we're going to do this for loop for as long as the length of the source array exists. So what is that? That's going to be 5. So as long as I is less than 5, which means that it'll loop 0, 1, 2, 3, and 4 as we bump I by 1 each iteration. And we're going to assign source array sub 0, which is 2, into target array sub 0. And that is essentially going to loop through 5 times and place 2, 3, 1, 5, 10 into the target array. That is one way in which we can go ahead and copy an array. I'm seeing an awful lot of discussion going on here. Let me see if there's something I need to address. Anybody have any questions? I see that there's a ton of comments here. Does anybody have any questions or comments for me? Nicholas, do you have any questions? Nicholas Grandforce? Nicholas, are you there? All right, well, I'm not getting a response. Anyone else care to bring up whatever issue is going on inside the chat room?
They're just talking about accessing the WebEx video that was posted.
Oh, okay. Well, if it's a private discussion, you don't need to send this to everyone. You can go ahead and select who you want to go ahead and have your private discussions with. Okay, so that's one way of copying an array, using a quick for loop and having a source array and a target array. There is another utility called the array copy utility. And you can use this by passing it. This is an array copy method where you're passing it a source array, a source position, a target array, a target position, and a length. For example, system.arrayCopy, whatever the source array is, starting at position 0 for the source, and the target array at the target position, and then for the source array length. And this will copy an entire array from the source over to the target, or you can go ahead and specify where you want it to start. Okay, passing arrays to methods. We have a method called printArray, and we are passing it an array as a parameter. Here's the type. It's an integer array, and inside this method, we're going to reference it as array. So this is now a reference variable called array. And what this is doing, it's doing a quick for loop and printing out each element in the array, followed by a blank. When you invoke this method, for instance, here we have a list array that's initialized right here to 312642, and we execute the print array, passing it the list parameter. It will now go ahead and, when you invoke the new method, you can go ahead and also do it a different way by invoking the method and declaring and creating this new array from within inside the parameter list. This is what's referred to as an anonymous array. It really has no reference variable. It's just an array that you can create kind of on the fly. It's referred to as an anonymous array. And that's exactly what I just said. We are at slide 51. I do want to go talk to you a little bit about bubble sorts. When we're working with arrays, up until now, the elements in the array are rather random. In other words, we've been entering scores, test scores, and they can come in any order possible. Or we can randomize the values inside an array, shuffle them, shift them, do whatever it is. But there's really no order to them. And in order for arrays to be very helpful to us, oftentimes we need to sort them in ascending order or descending order in order for us to process them effectively. Here's the opening problem from the PowerPoint, the Liang PowerPoint, and it says, supposing you were confronted with the challenge of reading 100 numbers and then to compute their average and find out how many numbers are above the average. Well, up until now, it hasn't been that hard to figure out the average is. But the second part of this problem is the real challenging part now, and that is how to find out how many numbers are above the average that you've calculated. Up until now, you've used for loops to do that. Using arrays, you'll be able to go ahead and do this complete problem without much difficulty at all. Let's first introduce arrays by getting the definition. An array is a data structure. Okay, that's a new concept. It's a data structure that represents a collection of the same types of data. Okay, so a data structure we'll talk about more in depth, but when you create an array, you have to keep in mind that the array is going to contain data that is of the same data type. Here's an example. We have an array of doubles. This is how you can read this. Okay, these left bracket, right bracket syntax indicates that we're going to declare an array. It's going to be of the type double, and we have a reference variable, myList, and that is going to be the reference variable for the array. This is the declaration part, and then the equal sign to the right of that is where we're going to actually create that array in storage. The new keyword will create the object, the array object, and this double keyword has to be the same as this double, and this 10 inside the brackets indicates how large the array is going to be. This statement here will go ahead and create this array referenced as myList, so you can think of that as a variable name, but it's actually a reference variable, which means that there's a pointer. This has an address. An area in storage gets created that has an address that points to the object of the type array somewhere else in storage. And when we issue this new keyword, it's going to actually allocate and create these 10 elements, and you can reference these 10 elements of type double by typing in myList sub 0, myList sub 1, myList sub 2, all the way down to myList sub 9. There are a total of 10 elements, and they contain the specific doubles inside those areas of storage. And it is zero-based, which means that the first element is myList sub 0. The second element is myList sub 1. It's going to be off by 1. The last element, myList sub 9, is really the 10th element in the array. The contents of that element is 11,123. The first element contains 5.6. Okay, so that's how you can understand what happens when you create an array. There are two ways that you can create an array or declare an array. The first way is to do it the way we just described, which is to declare the data type first, followed by the left bracket, right bracket, and then the reference variable name. There is another way, and the origin of this is derived from the C programming language. They decided to adopt it, but it's not used that frequently, and that is essentially to take the brackets and instead of putting them here, move them to the end of the reference variable name. Both work, but the second type, this double myList, open bracket, close bracket, semicolon, is not preferred. That's more for the C programming language. Here's repetition. We've already covered this. So we'll go to the next slide. And this really is repetition as well. This is what we just described here. This is declaring and creating all in one step. The left-hand side is declaring, the right-hand side is creating. Now, once an array is created, its size is fixed. You cannot change the size of the array that you have allocated in storage. You can find its size using the array reference variable .length. For example, in the case of the previous slide where we declared and created an array whose reference variable name is mylist, well, if you wanted to find out the length of that array, you can code in mylist.length, and that will return a value of 10. That gives you the length of the array. So you can know right then and there that the array has elements 0 through 9, if you need to reference those elements inside the array. When you create an array, its elements are assigned a default value. The default value for the numeric primitive types, that's int, that would be double, short, long, it's going to be 0. For the char data types, you're going to use the Unicode character, the \U, which is the escape character, and then 4 zeros. Now these are hexadecimal zeros representing half bytes. So we have 2 bytes being referenced here, and when you create an array of chars, it's going to be assigned a default value of hex zeros in each of the bytes, the 2 bytes for the char data type. And obviously false for Boolean types. We do know that Booleans can be true or false, that's it. And specifically, if you're looking inside the byte or the bytes, anything that is 0 is going to be false, considered to be false, and anything that is not 0 is going to be considered to be true. So declaring a Boolean type array will have zeros inside the elements, the value zeros. All right, index variables. The array elements are accessed through the index. Repeating what I said, the array indices are 0-based. In other words, it starts from 0 and goes to the array reference length, array ref var dot length -1. Each element in the array is represented using the following syntax, known as the indexed variable. And you can go ahead and put inside the brackets the index variable, the index of the variable, the reference variable, and you will then have access to that element inside the array. After the array is created, an index variable can be used in the same way as a regular variable. They're identical. You can think of them as being identical for that data type. For example, the following code adds the value in mylist sub 0 and mylist sub 1 to mylist sub 2. What we have here is an array of length 10. The first element in the array we can reference as mylist sub 0, whatever the value is inside that element, added together with mylist sub 1. I don't recall what was inside that array, but if you take those 2 values, add them together, and assign them into the third element in the array that you can reference as mylist sub 2. It acts just the same way as any other primitive data type in your previous assignments. Here's a way in which you can initialize arrays. So this is declaring, creating, and initializing all in one step. First thing we start off with is the data type. This is what's going to be inside each element in the array. So we have an array of doubles. The array reference variable is mylist, and we're assigning these values into the array. We now know that this is mylist sub 0, mylist sub 1, mylist sub 2, and mylist sub 3. So we have 4 elements in the array, and these are the actual values inside each of the elements. This shorthand statement must be done in one statement. In other words, you can't break it up into two. I think here they do that. So this statement here, which we just described, is the same as if you were to do this. Declaring an array of doubles, the reference variable name is myList, equals the new keyword. Now we're going to create an object in storage, and it's going to be of length 4 of doubles. And now you can assign any value you care to in each of the elements in the array. In this case, we're assigning 1.9 into the first element, 2.9 into my list sub 1, 3.4 into my list sub 2, and 3.5 into my list sub 3. This is wrong, so don't do this, which is basically to break it up and then do that. You need to declare it all in one step. We're going to trace a program right now. We have a public class test. Here is the actual class. It starts here, it ends down here, and we have a public static void main method starting right here and ending right here. And the first thing that we do is we declare and create an array of integers. The array reference variable name is values right here. And the new keyword will actually create this in storage, and it's going to be of length 5. As we described earlier, they are going to be initialized with zeros because it's a primitive numeric type int. We now have a for loop. And for int I equals 1, so we're declaring a loop control variable called I. It's going to be of the type int, and we're initializing it to 1. We'll go in this for loop for as long as I is less than 5. And for each iteration, we're going to bump I by 1. So I becomes 1. I is less than 5. 1 is less than 5. So we're going to execute the contents from within inside this for loop. What are we doing? We're taking I, which is 1, plus values, and here we have I minus 1. I minus 1 is 1 minus 1, so that's value sub 0. So we're taking the first element in the array, which is 0, and adding 1 to it, so 1 plus 0 gets assigned into values sub I, which is 1. That now gets placed in the contents of this element, in element 1, the second element. At the end of the loop, I gets incremented to 2. 2 is less than 5, so we continue iterating through the for loop. Now, what are we doing now? I, which after the line is executed, values sub 2 is 3, which is going to be equal to 2 plus 1. This is 2 plus value sub 2 minus 1. So that's down to value sub 1, so it's going to be 2 plus 1, which is 3. Now, that now gets assigned into value sub I, which is 2, down here. It's a little tricky, but it demonstrates pretty effectively that you can go ahead and assign variables, or excuse me, assign elements using this simple algorithm. Now I becomes 3. We still stay inside the for loop because it is less than 5. And now it's going to take 3 and add it to values 3 minus 1. And that's where we get 3 plus 3 is equal to 6. After this, I becomes 4. It's still less than 5. We still do the for loop. And now value sub 4 becomes I, which is 4, plus values of 4 minus 3, so 4 minus 4 plus 6 right here becomes 10. That gets assigned into values sub 4 over here. Next, I becomes 5, and it no longer is less than 5 because it's equal to 5. So we get out of the for loop, and we come down to this instruction right here. And it's got a little different approach to evaluate. We have to still assign something into element 0. And the way that they're going to do that is to add whatever is in value sub 1 together with value sub 4. So value sub 1 is 1 and value sub 4 is 10. So we're going to add 10 and 1. We're going to make it 11. And 11 gets assigned into the first element in the values array. And now you'll see that that's what happens. The next slides are some very handy routines to do some mainstream processing. The first is to initialize arrays. Let's look at this. We have, here's a snippet of code. We're first using the scanner for input, and we're going to ask enter as a literal string, concatenated with mylist.length. So that's a good application for when you want to identify the length of the array. And let's say the length is 5, so it will say enter 5 values, concatenated with the string values, colon, blank, close quote. So the console will have enter 5 values, and you're going to now go for int I equals 0 for as long as I is less than mylist.length. Okay, so that will go 0 through 4. And now we're going to go ahead and increment I for each iteration of the loop. We don't need curly braces for this because there's only one statement inside this for loop. And we will now get from the console input.nextDouble, because this is an array of doubles. My list is an array of doubles. And you can go ahead and enter doubles into your console, and it will get assigned into the first element in the array and continue through the fifth element, from element 0 up through element 4. That is a good way in which you can initialize an array using the console. Here's an example of initializing an array with random values. Same type of an approach. We don't need the scanner, but we can go ahead and do a quick for loop for int I equals 0, and we're going to go for as long as the length of the array. We're going to increment I by 1 for each iteration, and we're just going to go ahead and use this math.random method, which returns the fractional second from the system clock, and we're going to multiply it times 100. And that will randomly generate numbers, integers, from 0 to 99, and assign them into the element in my list. And it will do it for every element inside the entire array. So that's initializing arrays with random values. To print an array, for int I equals 0, and we're going to go for as long as the list length, the my list length is. We're going to just do system.out.print, my list sub 0, concatenated with a blank. We're using the print method, not the print line method, so this will now concatenate the elements in the array together with a blank in between each one as it loops throughout the array. It will print it out on one line. Okay, if somebody could please put their audio on mute, it would be terrific. Okay, here's summing all the elements in the array. First thing that we're going to need is an accumulator We'll call it total. It's going to be of the type double, and we'll initialize it to 0. Now we've got a for loop that will go from int I equals 0 for as long as my list length. And we are going to do total plus equals, which is the same thing as saying total equals total plus my list sub I. So we're accumulating every element in my list and putting it into the accumulator variable called total. When you drop through your for loop, you've gone through the entire array, and you've totaled every element therein. Finding the largest element in the array. We will go ahead and declare a double variable called max, and we're going to initialize it to whatever is inside the first element in my list. Okay, I'm getting some feedback, so if everyone could please put their audio on mute, it would be very helpful. Thank you. Okay, we lost that, I think. All right, so what's this first line doing? It's taking the first element in the array and assigning it into max. Probably a good idea, because as you traverse the array, the first element is going to be, at that point in time, the largest. So you'll assign max the first element's value. Now we're doing a quick for loop, and we're going to start with 1 instead of 0, because we already processed the first element. Whatever that value is the max. Now we're going to go for the remaining elements, and we're going to do for int I equals 1, and we're going to go for as long as I is less than my list.length. We're going to increment I by 1, and we're going to say if my list sub I is greater than the max. I'm not a big fan of this. It should be on 2 lines, but what they did was they did a shortcut, and they said, then we're going to assign that element into max. And this will continue and loop through the array. And if the next element is larger than what we've currently stored in max, it now becomes the new max until you're done with the array and you've dropped through this, this for loop. Any questions so far? I've done a lot of talking. I just want to make sure that people can pipe up and speak up. I want it to be interactive. Anybody have any questions? I'll just look to see if there's any raised hands. I don't see any. Anybody want to just make a comment? Okay, Alyssa says good so far. All right, so we'll continue on. All right, now this is a little tricky here, and this is random shuffling. I don't know that there's that much of a need to do that, but, and I'm not going to step through each one of these lines of code, but this is another for loop using I and J, loop control variables, I and J, and it does some, what is it doing? It's doing some random generating and swapping. I'll let you follow the logic in this at your leisure, but if you have a need to shuffle elements in the array, if you're creating a game of cards, for instance, and you want to shuffle the deck, this might not be a bad way to do it. You could create an array of 52 elements and shuffle the deck by using this random shuffling. I'll call it a method. It's really a for loop, but it is a method. Shifting elements in the array. We have a variable called temp. It's of the type double, and we're going to now put the first element in my list into the variable temp. We're retaining the first element. Now we're going to look to this good line comment here, shift elements left. So for int I equals 1, and we're going to go for as long to the end of the array. We are going to take my list sub I, my list sub 1, and enter it into my list sub I minus 1. That would be 0. So we're basically taking the second element in the array, that's my list sub 1, and moving it into the first element. And that explains why we saved the first one, because we didn't want to clobber it in the first iteration of the for loop. We saved it into a temporary variable. Now we can go ahead and follow this for loop, and it will continue on and keep shifting to the left each element by 1. And then you've got to go ahead and do something with this temporary variable after you've dropped through the for loop and move the first element from the temp variable over and put it in the last position. And that's essentially what this is doing here. It's taking the variable temp and putting it into mylist sub mylist.length -1. And that will put what was in the first element and put it into the last. That's shifting elements. The JDK Java Development Kit 1.5 introduced a new for loop that enables you to traverse the complete array sequentially without using an index variable. I don't know why they did that. Everything was working fine before JDK 1.5, but they went ahead and chose to do this. So for example, the following code displays all elements in the array called mylist. And just memorize the syntax. For double value colon mylist system.out.println the value. In general, the syntax for whatever the element type is, you can call it value, you can call it any conventional name, and the array reference variable name, and then process the value. You still have to use an index variable if you wish to traverse the array in a different order or change the elements in the array. But if you just want to do this very simply, they allow you to do this type of coding. Our opening problem: read 100 numbers and compute their average, and then find out how many numbers are above the average. All right, let's look at analyze numbers. Oh, okay, for you online folks, what I've suggested that the on-ground students do is, as you're going through these PowerPoints, and Ramil and Phil, and maybe this might be helpful to you, is what I ask people to do is to create a test chapter package in NetBeans. So in this case, I've created a test chapter 7 class inside this package. And whenever I get something inside a PowerPoint that I would want to test, I copy and paste it in and I execute it. And so all those PowerPoint slides that we just went through are all right here in workable code. I suggest you do that. It also, as you go ahead and copy and paste it and execute it and get it to run and troubleshoot it and clean up syntax, and you're going to have other questions that come up in your mind that may be easier to answer if you have this test chapter whatever, we're up to chapter 7 now, this test chapter 7 package available to you. So that's what I do, and I have this right here. I'm going to close this package out. I'll save it and open up Analyze Numbers. Here is the code, rather straightforward. Seemed like a pretty daunting problem when we first proposed this at the beginning of this webinar, but this doesn't seem like a terribly complicated solution now. Let's go ahead and take a closer look. We have a class called Analyze Numbers. It goes from here down to here, and inside there is one method. We're back to using just one method now, a main method, beginning here and ending there. So that's the whole class right here, is this main method. Inside the main method, we are declaring an array of doubles. The array reference variable name is scores, and when we use the new keyword, it will actually create that array. Its length is going to be 5. So now you can envision an array of length 5, so that's going to be scores sub 0 through scores sub 4. We're also looking to accumulate, because after all, we need this average. And then we're going to look to see how many grades are, or scores are above the average. So you'll need an accumulator variable. We'll call it sum of the type double. After all, grades could, or scores could be 97.5. So we want to declare them as doubles. We're going to get scanner input, and we're going to do a quick for loop. We're declaring I within our for loop as an integer variable. So for when I equals 0, and I will go for as long as scores.length, which is going to be 5, and we're going to increment I by 1. We'll bump 1 for each iteration. In here, we've done the scanner, so we're going to get system input, and we're going to enter a new score. The next double method inside the scanner class is going to take that entry and assign it into the scores array in that appropriate element number. In this case, it's going to be 0. So scores sub 0 is going to get the first score. What are we going to do next? We're going to take that first score, let's say it's 97, and accumulate it into sum. Sum plus equals 97 is the same thing as saying sum equals sum plus 97. So we are accumulating each of the scores for this test, or whatever it is that you're accumulating. We'll continue on for 5 iterations, and then at the very end, after the for loop, we've now gotten 5 scores inside our array, and we're going to take the sum and divide it by scores length in order to get the average, and assign it into the average of type double. Now we've calculated the average. Now we can go through this array again that we've created, and we're going to start by initializing a counter to count the number of elements above the average, and we'll do a quick for loop. We can use I again. We can declare it again because this I is only as good from there to there, so we can declare another declaration of I inside this for loop. We'll initialize it to 0, and we'll continue on for the length of scores, which is going to be 5. And we're going to ask the question, if scores sub I, which is 0, whatever that score is greater than the average, which is right here. The average is 70. Well, then we're going to add 1 to the counter. And then we will continue on, and for every score that's above 70, whatever our average happened to be, we're going to add 1 to our counter. We'll traverse through the array called scores until we fall through the for loop, and we will then go ahead and execute these last 2 print statements and say the average is, whatever the average is, I said it was 70 if that was the calculation, and then we'll go ahead and print out the number of elements above the average is going to reside in the variable called count. So it's a simple solution for what looked to be a rather difficult proposition, all by using arrays. Hopefully you all can see the value of using arrays, certainly with this simple problem. I'm going to run this program, and we'll get this to perform live. Enter a new score. I'm going to just put simple ones, and I'll put 1, 2, 3, 4, 5. So we can keep track of, easy to keep track of this. So I've entered 5 scores, 1, 2, 3, 4, 5. The average is 3, and the number of elements above the average is 2. That would be score 4 and 5. Okay, we got that? Everybody kind of got an idea as to how to use an array? And then using for loops. For loops are perfect for arrays because you know how long the array is. You can always get the array length by using the array reference variable name .length, and then loop through using a for loop through the entire array. And you can then take another pass through the array in another for loop. So it's a second analysis.